Good morning to one and all present here. A warm welcome to your second day of International Conference on Sustainable and Indigenous Technologies and Cultures, Multidisciplinary ICIT 2025. Let's begin with our day with a silent prayer. Thank you. I invite Dr. Ando PV, the chair of the technical session, to introduce our resource person.
Good morning to all. Esteemed guests, respected colleagues, and dear students. It is my great pleasure and privilege to introduce today's invited speaker, Dr. K. Multtidisciplinary sir, an eminent scientist, visionary, and one of the most respected figure in the field of material science and metallurgy. Dr. Multtidisciplinary is the former director of CSIR, Central Glass and Ceramic Research Institute, Kolkata, where he led a pioneer research initiatives and strengthened India's capabilities of advanced material, ceramics and high technology applications. His contributions have been widely recognized. He was awarded as a fellow of Electron Microscope Southern India Fellowship and a proud recipient of Defense Research Development Organization Agni Awards, honoring his outstanding work in the defense-related materials research. His academic foundations are equally impressive. He is an alumni of our college. He completed his PhD Metallurgical Engineering and postdoctoral work at Carnegie Mellon University, USA, one of the world's leading institutions in material science and engineering. Beyond his research achievements, he has played an important role in the strengthening India's scientific community. He is a founder member and former vice president of Microscope Society of India. Over the years, he has authored more than 50 research publications, supervised and produced 4 PhDs, and holds 2 awarded patents, testimonies to his relentless pursuit of innovation and excellence. Today, we are honored to have him speak on the topic that beautifully reflects his rich and diverse expertise in the topic material development at two laboratories, DMRL and CSIR, CGCRI. His insight will be undoubtedly provide us with a deeper understanding of the scientific advancement, challenges and national impact of material research in these premier institutions. I warmly invite Dr. K. Muralidharan sir to deliver his presentation. Thank you, sir.
Thank you, sir.
Thank you, Chairman. A very good morning to all of you. It's a very sultry day. The day is going to be like that. Maybe the week is going to be like that. So let's bring some cheer and celebrate the work of. Can you hear me without this? No. Do you have a neck mic? Because I like to move. Could you get me a neck mic? Cordless. Hello. Turn this off. Battery ഉണ്ടല്ലോ. The podium is mine for some time. Okay. So what we are going to do is maybe 55 minutes. We'll talk about the work I did at two national laboratories. The chairman just explained the kind of places I worked. So I happened to be fortunate enough to work at two leading national laboratories in the country. One is the Defense Metallurgical Research Laboratory, Hyderabad. The other is the CSIR's Central Glass and Ceramic Research Institute. In 1 hour, what I could cover is glimpses of this research, and I'll spend more time in two aspects, which is the work we did, two leading work in the two laboratories. So I thank the organizers of this conference for having invited me, and it was my wish to come and give a talk at St. Thomas College. I talked to many people. I came here once also to meet my professor and mentor, Professor N.R. Jairam, once, but I could not meet him, so I went back. So this is the second time I'm entering the campus after I graduated. Yesterday I took a look, went to the classroom where I studied in first PDC. It has changed a lot. I want to place on record my appreciation for the efforts done by the management to keep this college up to date, and the facilities are world class here, because I'll tell you, you are next to the major road here, and the Palakkad highway it is called, but in this room you don't feel any outside, so you're kind of isolated from this. So an ideal atmosphere for students to sit and do research, to read, and just adjoining you have one very impressive library. I've talked to the Reverend Father Principal to allow me to come and use this facility, this library. Okay, so what we're going to do is we'll go through some of the work I've done in these two laboratories. So the first of the laboratory is the Defense Metallurgical Research Laboratory. Any one of you on your tours and things like that have a chance to go there, please visit this laboratory. Let me know if you want to go. I will tell those people to admit you. Okay. The work I'm going to stress my importance is making steel for India's own aircraft carrier, INS Vikrant, which was launched about 3 years back by the Prime Minister in Kochi. The ship was fully built in the Kochi shipyard. So it's a proud moment for every Malayali that a ship built in Kochi is ready. It has already joined the Indian Navy and is right now undergoing the very final trials. And I think mid 2026 it will be battle ready. But in between, the recent war we had with the recent conflict we had with Pakistan, the INS Vikrant did a major role, and because it carried the sailors in the ship, and from that ship we fired salvos at Karachi. It was all came in papers. It came one day, and next day it was withdrawn for strategic reasons. But INS Vikrant, during its induction, it's not yet ready. During the induction, it showed it what it can do. So INS Vikrant is a ship on which, on the deck itself, you can have 14 aircrafts and 2 helicopters, and it is a mini township, and it can, the power required to run the ship is probably the power, maybe twice the power that a major city like Bombay has. So it's like a mini Bombay in the sea, serving the armed forces. So my job was to make the steel for that. The steel which is DMR 240. Okay, I'll come to that. Okay, before that, a story about India's warship history. This is what is called, I'll come here, it's easier to, because I can't read my own slides. That's when I first wanted to wear specs. Okay, so it's here. Okay, this is good. So we had used a warship which was built by the United Kingdom, and it was decommissioned some time back. And later, in 1957, we purchased another ship, which was called Vikrant. And Navy has a tradition, they give the same name to the new ship coming in. That's why INS Vikrant 2, it is the same INS Vikrant, it's the same name continuing. And that served us well, and those of you who remember, it did extremely well in the war we had with Pakistan, which led to the creation of Bangladesh. Bangladesh in a mess today, again, doesn't matter. But Sheikh Mujibur Rahman was made the Prime Minister of Bangladesh by Mrs. Gandhi. It was a military war which we won. Okay, General Manekshaw won the war for us, and Sheikh Mujibur Rahman, who is the father of the current exiled Prime Minister. Okay, so the ship did very well in this war, and what happened to the ship is it was scrapped in the year 2014. So INS Vikrant was a hero of the, I've told you all this, and INS Vikrant was a British aircraft carrier, and it is finally reduced to a heap of scrap. Those youngsters here who are interested in owning a part of INS Vikrant can go and buy. I don't know the picture. You can buy it as a motorcycle. So today motorcycles are made with the scrapped INS Vikrant. Later we had an indigenous plan to make an aircraft carrier, which is INS Vikrant. Okay, and this ship is, I'll show you the pictures of the ship, which is already now ready. So the program was started in September 2013, So this is the new INS Vikrant, and you can see the length. It is like a mini, so it's like a building. Okay, its length is 262 meters, and the construction started in Kochi shipyard in 2009, and the total cost with escalations everything is 23,000 crores. And this is more important, only few countries have the capability to have an aircraft carrier, and India is probably the 4th or 5th country to have a aircraft carrier. So these are the full detailed specifications of the INS Vikrant 1, IAC 1 as they call it, and I roughly told you the number of people it can save, like a mini station, and the dimensions are given. I'm sorry, dimensions, and yeah, so I don't have a pointer. Pointer is here. This is a pointer. Will it work on this? Pointer won't work on this? Okay, fine. So it can have 15-60 persons on it. It can have MiG-29Ks and LCA Tejas, as well as 2 helicopters. And the construction in Kochi took time from 2009 to 2013. That's kind of prime research career of mine. So I used to frequent Kochi, solve the problems. They say this steel in Vishakhapatnam, steel in Rourkela is not doing well, so I should rush to Rourkela. Then, so that's what we did. So finally, it was commissioned in the year 2022. For the last 3 years, it has been going fitment trials and sea trials, because for a ship to become fully seaworthy and engage in operations, it takes that kind of time, and it had to be weaponized. So weapons had to be put on that, plus the real power, the diesel generator of the ship had to be bought from France and put up. So what we say so much about the indigenous, Indian Navy has taken a decision to become a maker's navy. That means we make whatever we can. So today, if I tell you, 72% of the aircraft carrier is Indian material, and out of that 72%, around 48% is our steel, which is made by DMRL. So I'll tell you the story of building that, making that steel. Okay. So this is like a, even if I had to stop my presentation now, I've told you enough in this slide. Okay. So it's like a full resume of what is there in the making of the steel. So Russians were using a class of steels called AB class of steels, and they were special steels, and the steels were developed by Russians using thermodynamic principles. So it is, all of us says Russians are way back in mathematics. They are not mathematics, they are way back in electronics and things like that. But they were extremely bright in ship construction. They were extremely bright in thermodynamics calculations, mathematics. So they developed the entire steel using thermodynamics equations, and this company called CRISM Promethe. Does anyone know who's Prometheus? Anybody? You go for those classes, no? Prometheus is a god who stole fire from, he's a person who stole fire from the gods. Fire, fire. So the gods cursed him and said, your belly will always be on fire. So, but then what happened, since he did such a remarkable job for the human beings on earth, there was a counter, anti to his curse. He said, whatever cells are burned by the fire will be rebuilt. So Prometheus is a man who has a burning belly and he moves around. So he is supposed to be a aid of the Indian, of the human beings. So the company which, the laboratory in Russia called Promethe is named after Prometheus, the, the person who stole fire from the gods and brought it to human beings, to humanity. So CRISM Promethe was our consultant, and the technology of making this steel was available to us. We purchased this, DMRL purchased this through Indian Navy. Then the job was that when you look at these details you get, you find all this is catering to the Russian principles, the Russian plants. So we have to adopt the entire technology for Indian plants. So which are the Indian plants we are using? We are using Bhilai, Rourkela and Bokaro. So certain products which is listed here is made in these different parts, mainly plates and bulb bars. Okay, and there were two grades in the AB class called DMR 249A and DMR 249B. The strengths are given here. Oh. There is no pointer, is it? You don't have a pointer, which you do not work on this. Okay, fine. I'll move there. So the strengths are more for the AB2. The AB1 is 390 MPa strength. This is 598 or 600 MPa strength. And you can see we make bulb bars as plates. This is what makes the ship. The hull of the ship is made by DMR 249 A and B material, and the flight deck on which the aircraft lands and takes off, which is important for the aircraft carrier, that is made by the steel 558 MPa steel, which is AB2. And we rechristened them DMR 249A and DMR 249B. You might ask me, why are you naming it such a crazy name, you know? There's a good name called AB1, AB2. So we called it like this because my boss, Mr. Sarvaranjan Sahai, is no more with us. He said, he was asked to name the ship, name the steel. He said, I'll give it my project number. So 249 is the project number allotted to DMRL by DRDO headquarters. So that's the name 249. You know, it happens, some kind of luck is there. When we were in a press conference in Delhi with the entire press in Delhi, SAIL chairman, Mr. Rungta, claimed it as SAIL made steel. He said SAIL, it is SAIL. They always say there's a bit of SAIL in everything, no? SAIL. So one reporter asked, if your steel is called SAIL steel, why didn't you give it the name SAIL? Why is it called DMR and 249? Then the poor fellow had to reply saying that this steel was developed by the Defense Metallurgical Research Laboratory and it's their project number. So what Sahai did without knowing turned out to be very good for us because I didn't have to defend it. So that's a story. So the interesting thing is the steel now beats any other steel, and we made it in India with indigenous raw materials, and we qualified the entire steel for the tonnage quantity required to make the ship. And when we made it, they said, can I use this steel for other purposes in the Navy? Now if you look at a naval stockyard, they at that point of time, they had 37 varieties of steel. those of you who are looking at inventory, many of your project students, they may be looking at in what inventory does the teacher or your guide contains. Maybe 17 item, 18 item, 22 different steels, they have to be classified and kept. So we told them, if you want to use tomorrow one particular steel, this particular steel 249A can replace all of them. So 37 number of steels inventory will reduce down to one steel. Easily said and done, but we have to go and prove that this can weld, repair and cross weld with all kind of other steels. So we did all that work. So this is the work we did. I just want you to realize that point. But today they're very happy, and we had support from our sister laboratory called NMRL, Naval Materials Research Laboratory in Ambernath in Pune. And all this steel, so we'll give you a glimpse of the story of what we did. Okay, so these are the two classes of AB class of steels. It basically formed the bulb bars and the plates, and there are many other components. The present status is we have supplied the required status. It's a long time backstory, about 5 years backstory, maybe 3 years backstory. Okay, those of you are interested in details, this is a plain carbon, almost a plain carbon steel 249A. The 249B is quenched and tempered steel, and the properties are given here. And the most important thing is what is called Charpy V-notch energy, that is, it is so ductile. A ship has to go to sea where the temperatures are lower, cold temperatures, so it should withstand that. So that is indicated by the capability that the steel won't crack down even at minus 60 degrees centigrade after prolonged usage. So we met all these properties in all our have questions, somebody? Oh, okay. So the story goes like this. First time we did, we were beginners, so to say, steel metallurgy those days. So we made it by the cleaner's route. So the first melt we took a 30 kg, 30 ton melt in HEC Ranji. Okay, we processed it and made plates. And the second melt we did, we made some modifications and we went to rolling at HEC. I mean, from HEC we took it and rolled it at Bokaro. Now, at this point of time, we met the Navy people and they said, your steel is good, but its cost is 3 times the cost, 2.75 times the cost of the imported steel. Imported steel is Russian steel. So we said to bring it down. So our job is that we took the challenge and we said bring down the cost of the making the steel. So we introduced 2-3 different processes, which is what I'll tell you, and we made metallurgy route and followed almost similar to, we can see the fine details of that, almost similar treatment as what the Russians do. So then we did, this is the DMRL's job, we introduced what is called a CC route. When you make plates, this is what is continuous casting. The advantage is that the yield goes up from 70% to something like 90 to 93%. I would say even 100%. So yield itself, there is saving. Then the heat which is put into the steel is still used for the rolling purpose. So continuous casting route made us, the steel became 1.2 times the cost of the imported steel. So Navy said, okay, that 20% extra cost we will bear. But we said no, we will try to make it even cheaper. Okay. So then what we did is, one is what I said, to make the steel cost effective, we did continuous casting. This is the process, the turn dish, and the steel as is poured here, it is continuously made to go into the rolling mill. Okay. So no heat is lost. So that is first thing we did. Second thing we did is, we improved, okay, the other thing is not here. Okay. So we said continuous casting, then we said the rolling process itself in Rourkela steel plant, we introduced certain steps in the rolling, in the continuous rolling. The combination of introducing continuous casting and controlled rolling, the two processes we started doing in DMRL, we made the steel at 80% of the imported steel cost. Okay. We started with 2.8 times, today is 80%. The Navy is very happy. The commander will take you for a drink. Okay. So essentially the success lies here, that the fundamentals of metallurgy or material science you learn in school, what you learn in St. Thomas College here, what I learned here, so those are to be used in practice in real life. So we made the steel cheaper, and thereby the flight deck was made. The flight deck story is the next. So we found on inspection of this flight deck, that there were some problems. So we had to introduce a new step called hot leveling. So we introduced hot leveling. Through hot leveling it became successful. That's why the flight deck was also made. So all this means Muralidharan can't sit at home, relax. So when they call you, you have to rush to Rourkela. How do you do that? There is no flight, so you have to go by train. So you go by train and solve the problem and come back. Okay. Everybody will be unhappy, the wife will be unhappy. But finally, when the steel is made and the aircraft carrier is launched by the Prime Minister, you forget all that. Okay. Okay. So this is some details of the work. So we also found that these data points are our data points, and this is ductile brittle transition temperature of the steel, and you find all of them qualify that, nothing is over here. Okay. So that's the story. I've taken one example of what I did in DMRL. And DMRL we did some more things. So when we chat in the afternoon, in the second half of this forenoon itself, with others we'll talk to that. In 2015, yes, I moved to Kolkata because I found that in spite of all this work I did, there's very little room left on top. The top position is held only by one person, isn't it? So there are multiple people vying for that position of the scientific advisor to Raksha Mantri. So I said I just move out of this race. So I moved and went to Kolkata and headed this laboratory called Glass and Ceramic Research Institute at Jadavpur, which is a part of the CSIR laboratories. How are we doing with time, sir? Time wise? So half an hour more is there. We started at 9:30, is there? So if we are done, is that time wise? Okay. Give me 5-10 minutes, I'll just quickly burst through. So this laboratory, CSIR, it's the first CSIR laboratory set up in the country, and it was set up, this picture shows this Vidhan Chandra Roy, who was a great surgeon also, a great physician, and he inaugurated the laboratory. And the laboratory had three purposes: characterize raw materials, help the ceramics industries grow in the country, and train the required manpower. Do we have an online presentation or something after this? Organizers? Is there a time? 5-0. So we have gone past that, no? Oh, 10:15 you have online. Okay, fine. So I'll skip the mission. I'll leave the slides here, all of you can read it. Okay. So we look at some key research areas of this. So if you look at the sustainable development goals of the country, we work in many of those areas of importance. Okay. And we make, for example, lasers. We are the only laboratory in the country which makes lasers, and we make beads for nuclear industry. We make radiation shielding windows for it in industry. We make fiber gratings. We make radomes. This is RBSN, reaction bonded silicon nitride radomes for the missile program. Make SOFC, which is solid oxide fuel cells technology, and we also work on high speed cutting tools. So we did glass slabs for specialty refractory crucibles, and this is one job BRC wanted us to do, Atomic Energy wanted us to do. So we used, it was traditionally made by platinum pots, so we made it using refractory crucible. The property between their specifications and what we made, and this is the process by which we make these slabs. These slabs are required to stop the neutron radiations to go through, to stop the nuclear radiations from affecting the people. So it's a glass window like this. So through the window you can see the operation going on that side. The operator is not affected by this because you lead glass. This lead contains 78% lead in the glass. It's lead oxide, sorry, not lead oxide. So we made 400 by 400 by 100 big thick slabs. Some of the pictures are shown here. The paucity of time, we made a process by which we could make it not by platinum pot technology, but by this refractory pot technology. So this technology is now ready, and we have transferred the technology to HR Johnson, which is called Prism Johnson now. Okay. So this is between BRIT, which is a board for radioisotopes, and CGCRI and Prism Johnson. So indigenization of countries' efforts and developing the technology for the country. So our people got awarded by the president, giving them the award for this work. And this is the most important thing if I did in CGCRI is develop this radomes. Radomes are radio, this is a shield which goes around the electronics, and it protects the electronics from getting affected. So this is the shape of it. It is the nose of the missile it goes. So I think the next few slides we'll just have the story. So what is the radome is shown here, an incoming missile here. The radome is at the very top of that aircraft. Okay. So we made these radomes in silicon nitride, and this was a technology denied to the country. And I had 5 years to make this, and we were successful in making it. We have made 7 radomes and supplied to RCA, which is Research Center Imarad, which is part of DRDO's missile laboratories, and we have made another 15 radomes for a smaller size. So this technology is established for the first time in the country, which only Ceradyne in the US had the technology to use silicon nitride radome. It uses near net shape processing technique. Because paucity of time, I'm not going through the details of that. So these are the number of radomes we made, And the size of this radome is 1 meter long. It's not a small thing. Okay. This is half meter. So we met all the properties here. And this is the first furnace I worked with. You can see the radome here is sitting in that furnace. This is a furnace we purchased. This is old furnace we had. Then we purchased a new furnace by which we made all this radome. Those are the 7 radomes we supplied. And the entire process sheet is given here. There is a very complex process, but we did make these. These are the microstructures of these radomes. And these are the properties of these radomes, where you can see the targeted property is meeting in the loss tangent. We are better than the specification given to us. And these are the heating cycle we have the radome. And this is just when I was leaving CGCRI. They did the work and they made this radome and supplied it. The job is now complete. And I think this we can also do ultrasonic tests of these. And this is 1 meter tall radome which we made. And we got a letter of appreciation from the then director of RCI, Dr. Murthy, who is now director of DIIT in Pune. Okay, so we also did some work with space, and we made this different quality of space quality glasses. Okay. I'll give you some, these are the fiber black gratings we made, and they are used in applications by TBRL. So fiber black grating, entire technologies with CGCRI. Okay, so if you look at the fiber black grating story, many companies like VSSC, ISRO, NAL, NTPC, BHEL, all of them come to us, and we have made all these products for them. This I leave, skip this. So we also did some work with cleaning the water cleaning. So this process is set up in the laboratory, so we can now give pure drinking water to community. And we also worked on restoration of heritage structures. And one work, I probably come back and talk to you about the work we did with the Moon Mission, where we make a human habitat on the surface of Moon. So it will be a talk by itself. And this is one specific work we did, which was appreciated by Dr. Kalam. It was a long time back he did that, but we completed the work. We saved significant amount of money, which is nearly about 2,000 crores at that point of time. It may be even 3,000 crores today, where we don't import any of these raw materials from other countries. So this was appreciated by Dr. Kalam those days. And there's a place called Kurja. Those of you who travel to north, please go to Kurja. The Kurja looked like this some years back. Today it looks like it's so we help in cleaning up this. And this is just a nutshell of what we are today. So these are the technologies we have worked on, we developed, and these are our users. Okay. So I just put a snapshot of all this. Okay, so I acknowledge the support of my entire team, many people I worked with. So all of them I thank, both at DMRL and DRDO, the chairman of these three organizations, DRDO, DAE and ISRO, DGCSAR, my colleagues at the laboratories, DMRL, CGCRI and CIM at Thrissur, where I am now. just completing that. So, thank you. I'm sorry.
Thank you, sir. Any inquiries, please?
Any questions? Or we can also interact later because they have another program starting at 10:59. I think it's an online talk by somebody.
Thank you, sir, for informative talk. I invite Dr. Ando PV for the conclude the session.
Good morning to all of you.
You want this?
Good morning. As we come to the close of this highly insightful session, it is my privilege to offer a brief conclusion, remarks, and extend my heartfelt thanks. We have just listened to a truly enriching and thought-provoking lecture on material development at two premier laboratories, DMRL and CSIR CGCRI. Dr. Multtidisciplinary sir has taken us through the remarkable scientific journey of these two institutions. One contribution extensively to our nation's strategic defense materials and other pioneering advanced research in glass, ceramics, steels and other functional materials. Through this comprehensive presentation, Dr. Multtidisciplinary has highlighted not only the technological breakthroughs achieved at the DMRL and CGCRI, but also the spirit of innovation, interdisciplinary collaborations, and national services that drive these organizations. His deep insights, drawn from decades of leadership and hands-on research, have given us a much clearer understanding of the challenges, achievements, and future possibilities in the field of advanced materials. He brings our nation's product to the international level. On behalf of all participants, organizers of ICIT 2025 and St. Thomas College, I express our sincere gratitude to Dr. Multtidisciplinary sir for sharing his expertise and inspiring us with the knowledge and experiences. His talk has undoubtedly broadened our perspectives and offered valuable guidance to researchers and faculty, students alike. I also extend my thanks to the organizers for arranging this excellent session, to my fellow colleagues for their support, and to all attendees for your active participation and keen interest. With that, we formally conclude this session. Thank you all of again and have a wonderful continuous program ahead. Thank you.
Thank you, sir. I request Dr. Chaco VM, former Dean of Research, Senate Member of University Calicut, to hand over the certificate and token of love from St. Thomas College, Thrissur to Multtidisciplinary sir. After tea break, we will begin our paper presentation competition. Participants, please confirm your PowerPoint and please be present after the tea break. Feedback. Dear participants, please note that there is display the QR code for the feedback. Please scan and submit your feedback. Thank you.
സുഖമെഴുതിയ സുദിനം പ്രിയകരമതിമൃദുലം ശുഭകരം മനഹിതം അണിയുക കനകം താരമുകിൽ പൂവുകളിൽ മഞ്ഞു പകരുന്ന മധുഗണം സ്വർണ്ണമുഖി ഗോൾഡ് ആൻഡ് ഡയമണ്ട്സ് പ്രൈവറ്റ് ലിമിറ്റഡ് മാർ ടവർ ബിൽഡിംഗ് മണ്ണാടിയാർ ലെയിൻ തൃശൂർ. സൂര്യപ്രഭയുടെ സ്വർണ്ണമുഖം.
എന്താ കുട്ടി ഇത്?
കൺമുന്നിലെ തിരശീലകൾ കനവുകൾ തുന്നുന്നു പഴയ കാലം. എത്രയോ വർണ്ണങ്ങൾ എഴുതി മായ്ക്കുന്നു മങ്ങാത്ത മിഴിവുറ്റൊരക്കാലമേ കാലമേ.
ഇതെന്റെ മുത്തച്ഛന്റെയാടാ, അധ്യാപകനായിരുന്നു.
ഇപ്പൊ നല്ല പഴക്കം കാണുമല്ലോ. ഇത് പിടിച്ചേ, ഇപ്പഴും നല്ല ഭംഗിയുണ്ട് കേട്ടോ.
എന്റെ കൂട്ടാ,
ഇത് എവിടുന്നാ വാങ്ങിയേ?
നീ ഇത് എവിടുന്ന് വാങ്ങിയോ? അവിടെ തന്നെ.
Day1 ഒപ്റ്റിക്കൽസ്, കാഴ്ചകളുടെയും സ്നേഹബന്ധങ്ങളുടെയും തിളക്കം എന്നെന്നും നിലനിർത്തുന്ന 100 വർഷത്തെ പാരമ്പര്യമുള്ള സ്ഥാപനം. എംഒ റോഡ് Day1 ബ്രാഞ്ചിന്റെ കീഴിലുള്ള ഏക സ്ഥാപനം ഇപ്പോൾ പൂങ്കുന്നത്ത് വിശാലമായ കാർ പാർക്കിംഗോടുകൂടെ പ്രവർത്തനം ആരംഭിച്ചിരിക്കുന്നു.
അനുദിനം മാറിക്കൊണ്ടിരിക്കുന്ന ഒന്നാണ് വിദേശ രാജ്യങ്ങളിലെയും സർവകലാശാലകളിലെയും പോളിസികൾ. ഈ മാറ്റങ്ങൾ വ്യക്തമായി മനസ്സിലാക്കാതെ അവിടങ്ങളിലേക്ക് പോകുന്നത് പ്രതീക്ഷിച്ചതിന് വിപരീത ഫലമായിരിക്കും ഉണ്ടാക്കുക. അതുപോലെ തന്നെ പ്രധാനപ്പെട്ടതാണ് ഓരോ വിദ്യാർത്ഥിയുടെയും താൽപര്യവും സാമ്പത്തിക സ്ഥിതിയും അറിഞ്ഞ് അഭിരുചിക്കിണങ്ങുന്ന കോഴ്സ് തിരഞ്ഞെടുക്കുക എന്നതും. കഴിഞ്ഞ 30 വർഷത്തിനു മുകളിലായി ഇന്ത്യയിലെ വിദ്യാർത്ഥികൾക്ക് വിദേശ വിദ്യാഭ്യാസത്തെപ്പറ്റി വ്യക്തമായ മാർഗനിർദ്ദേശങ്ങൾ നൽകിയും അവരെ അതിലേക്ക് കൈപിടിച്ച് നടത്തുകയും ചെയ്യുകയാണ് കൊച്ചി കലൂരിലെ ഗ്ലോബൽ എഡ്യൂക്കേഷൻ കൺസൾട്ടന്റ്. വിദേശ വിദ്യാഭ്യാസം എന്നത് മലയാളികൾക്ക് അപരിചിതമായിരുന്ന കാലത്താണ് ഗ്ലോബൽ എഡ്യൂക്കേഷൻ കൺസൾട്ടന്റ് വിദ്യാർത്ഥികൾക്ക് ലോകത്തിലേക്കുള്ള വാതിലായത്. ബ്രിട്ടൻ, USA, ഓസ്ട്രേലിയ, അയർലൻഡ്, ന്യൂസിലാൻഡ് തുടങ്ങിയ രാജ്യങ്ങൾ മലയാളി വിദ്യാർത്ഥികൾക്ക് വിദൂരമല്ല എന്ന് മനസ്സിലാക്കിക്കുന്നതിൽ ഗ്ലോബൽ എഡ്യൂക്കേഷൻ കൺസൾട്ടന്റ് വഹിച്ച പങ്ക് ചെറുതല്ല. 1993 കൊച്ചി കലൂരിൽ വളരെ ചെറിയ രീതിയിൽ തുടങ്ങിയ ഗ്ലോബൽ എഡ്യൂക്കേഷൻ കൺസൾട്ടന്റ് വിദേശ വിദ്യാഭ്യാസ ഭൂപടത്തിലെ പ്രധാന നാഴികക്കല്ലാണ്. വിദേശ വിദ്യാഭ്യാസ സേവനങ്ങൾ നൽകി തുടങ്ങിയ കേരളത്തിലെ ആദ്യകാല സ്ഥാപനങ്ങളിലൊന്നുകൂടിയാണ് ഗ്ലോബൽ എഡ്യൂക്കേഷൻ കൺസൾട്ടന്റ്. വളരെ സാധാരണക്കാർ തുടങ്ങി സമൂഹത്തിലെ എല്ലാ വിഭാഗത്തിനും വിദേശ വിദ്യാഭ്യാസം സാധ്യമാക്കുന്നതിൽ ഗ്ലോബൽ എഡ്യൂക്കേഷൻ കൺസൾട്ടന്റിന് സാധിച്ചിട്ടുണ്ട്.
ഇനി വോൾട്ടേജ് പ്രശ്നങ്ങളും മിന്നലും നിങ്ങളുടെ ഉപകരണങ്ങൾക്ക് ഒരു പ്രശ്നവും ഉണ്ടാക്കില്ല. തേർഡ് ഐ സെക്യൂരിറ്റി സിസ്റ്റംസ് അവതരിപ്പിക്കുന്നു സർജ് പ്രൊട്ടക്ഷൻ ഡിവൈസ്, ലൈറ്റ്നിംഗ് അറസ്റ്റർ ഡിവൈസുകളുടെ ഇൻസ്റ്റലേഷൻ സർവീസ്. വോൾട്ടേജ് ഇഷ്യൂസ്, മിന്നൽ മൂലം ഉണ്ടാവാൻ സാധ്യതയുള്ള അപകടങ്ങൾ എന്നിവയിൽ നിന്നും രക്ഷ നേടാൻ ഈ ഡിവൈസുകൾ നിങ്ങളെ സഹായിക്കും. സെക്യൂരിറ്റി സിസ്റ്റംസ് മേഖലയിൽ കാലങ്ങളുടെ എക്സ്പീരിയൻസ് ഉള്ള തേർഡ് ഐസ് മികച്ച ഗുണനിലവാരമുള്ള പ്രൊഡക്ട്സ് മാത്രമാണ് നിങ്ങൾക്കായി നൽകുക. അതുകൊണ്ട് തന്നെ നിങ്ങൾ സുരക്ഷിതരായിരിക്കും. ഉടൻ തന്നെ സമീപിക്കൂ തേർഡ് ഐ സെക്യൂരിറ്റി സിസ്റ്റംസ്. സുരക്ഷയുടെയും സൗകര്യങ്ങളുടെയും കാര്യത്തിൽ നാടും വീടും ഹൈടെക് ആവുമ്പോൾ അറിവും ടെക്നിക്സും ഒരുപോലെ പരിശീലിക്കാം എക്സ്ട്രീം റേഞ്ചിൽ തന്നെ. നിങ്ങളിലെ ഫ്യൂച്ചർ ഡിജിറ്റൽ ടെക്നീഷ്യനെ കണ്ടെത്താൻ ഇക്വിനോക്സ് അക്കാഡമിയിലൂടെ തേർഡ് ഐ ഒരുക്കുന്ന അഡ്വാൻസ്ഡ് ട്രെയിനിംഗ് കോഴ്സസ്, സെക്യൂരിറ്റി സിസ്റ്റംസ്, ഓട്ടോമേഷൻ, എനർജി സൊല്യൂഷൻ എന്നിങ്ങനെ വിവിധ മേഖലകളിൽ അറിവ് നേടാം. OEM സർട്ടിഫൈഡ് ട്രെയിനേഴ്സിന്റെ നേതൃത്വത്തിൽ ഓൺ സൈറ്റ് ട്രെയിനിങ്ങിലൂടെ കഴിവ് തെളിയിക്കാം. ബേസിക് ഫണ്ടമെന്റൽസ് അടങ്ങുന്ന കൃത്യമായ പരിശീലനത്തിലൂടെ. കൂടാതെ ലോകോത്തര നിലവാരത്തിൽ ലോകമെമ്പാടും അനവധി തൊഴിൽ സാധ്യതകൾ. നാടിന്റെയും നിങ്ങളുടെയും ഭാവി സുരക്ഷിതമാക്കാൻ ഹൈടെക് വേൾഡിലെ ഹൈ ക്ലാസ് അക്കാഡമി ഇക്വിനോക്സ് അക്കാഡമി. നാടിന്റെ ഹൈടെക് കാവലിന് അറിവിന്റെ ടെക്നിക്കൽ സപ്പോർട്ട്.
സ്റ്റോക്ക് മാർക്കറ്റ് ഇൻസൈറ്റ്സ് എപ്പോഴും എവിടെ നിന്നും അറിയാൻ ഇപ്പോൾ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ മൈഫിൻ TV ആപ്പ്.
Innovate your financial knowledge with the latest updates on MyFin TV. Download the app now. Level up your financial game with MyFin TV. Download the app now.
സാമ്പത്തിക സംശയ നിവാരണങ്ങൾക്കായി ഇപ്പോൾ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ മൈഫിൻ TV ആപ്പ്.
നിറമെഴുതിയ സുദിനം പ്രിയകരമതിമൃദുലം ശുഭകരം മനഹിതം അണിയുക കനകം താരമുകിൽ പൂവുകളിൽ മഞ്ഞു പകരുന്ന മധുകണം
സ്വർണ്ണമുഖി ഗോൾഡ് ആൻഡ് ഡയമണ്ട്സ് പ്രൈവറ്റ് ലിമിറ്റഡ്, മാർ ടവർ ബിൽഡിംഗ്, മണ്ണാടിയാർ ലെയിൻ, തൃശൂർ. സൂര്യപ്രഭയുടെ സ്വർണ്ണമുഖം.
എന്താ കുട്ടി ഇത്?
കൺമുന്നിലെ തിരശീലകൾ കനവുകൾ തുന്നുന്നു പഴയ കാലം എത്രയോ വർണ്ണങ്ങൾ എഴുതി മായ്ക്കുന്നു മങ്ങാത്ത മിഴിവുറ്റൊരക്കാലമേ കാലമേ
ഇതെന്റെ മുത്തച്ഛന്റെയാടാ. അധ്യാപകനായിരുന്നു.
ഇപ്പൊ നല്ല പഴക്കം കാണുമല്ലോ. ഇത് പിടിച്ചേ. ഇപ്പഴും നല്ല ഭംഗിയുണ്ട് കേട്ടോ.
എന്റെ കുട്ടാ.
ഇത് എവിടുന്നാ വാങ്ങിയേ?
നീ ഇത് എവിടുന്ന് വാങ്ങിയോ? അവിടെ തന്നെ.
TBNU ഒപ്റ്റിക്കൽസ്, കാഴ്ചകളുടെയും സ്നേഹബന്ധങ്ങളുടെയും
കണക്ട് ചെയ്തിട്ടുണ്ട്. വന്നിട്ട് ആണോ? പിന്നെ എന്താ എന്തെങ്കിലും ചെയ്യാനുണ്ടോ? മറ്റേ PC മോഡോ അങ്ങനെ എന്തെങ്കിലും ചേഞ്ച് ചെയ്യാനോ? ഒരെണ്ണം കൂടി കുത്തിക്ക് എന്നെ കാണാൻ 8 പേരാണോ? 5 പേര് ഉണ്ട്. എല്ലാവരുടെയും ഉണ്ട് ഇപ്പോൾ. എക്സ്റ്റെൻഡ് ചെയ്യണത് എവിടെയാണ്? സെറ്റിങ്സിലാ സെറ്റിങ്സ് എവിടെയാണ്? ഇവിടെ ഉണ്ടല്ലോ. അതന്നെ ഇവിടെ ഉണ്ട് സെറ്റിങ്സ്. മൗസ് കാണാനില്ലേ? മൗസ് അങ്ങോട്ട് പോയിട്ടുണ്ട് അവിടെ. ഇത് ഊര് ശരിയാലോ. ഇതൊരു എൻ്റെ സ്ക്രീനായി പ്രശ്നമാണ്. അത് എനിക്ക് സെറ്റിങ്സ് എടുക്കാം. ഇന്നലെ പ്രശ്നം ഉണ്ടായില്ലേ? കുഴപ്പമില്ല. സിസ്റ്റം അടിച്ചോടാ. കുത്തി ഡിസ്പ്ലേ അല്ലേ? അറിയാം. ആണോ? പക്ഷെ ഇന്നലെ അല്ലാണ്ട് എന്തായാലും സെറ്റിങ്സിലെ ഡ്യൂപ്ലിക്കേറ്റ് ചെയ്യണം. അതാരെങ്കിലും മാറ്റിയിട്ടുണ്ടാവും അല്ലേ? പഠിക്കേണ്ട ജോലിയിട്ടൊക്കെ അല്ലെങ്കിൽ പിന്നെ എന്ത് ചെയ്യും? സെറ്റിങ്സിൽ പോയിട്ട് സ്ക്രീൻ മാറ്റിയിട്ടുണ്ട്. സെറ്റിങ്സിൽ പോയിട്ട് സ്ക്രീൻ മാറ്റിയാൽ മതി. ഫസ്റ്റ് തന്നെ ആരാ? ഫസ്റ്റ് ആൽവിൻ പോയി.
Once again, good morning to one and all. Let's begin our paper presentation competition. Today we have the judges. Dr. Sunil Josri, Associate Professor, Department of Chemistry, St. Thomas College, Thrissur. Dr. Nees Paul, Associate Professor, Department of Physics, St. Thomas College, Thrissur. And Dr. Ando PV, Associate Professor, Department of Botany, St. Thomas, Thrissur. I hope all the participants are present in the hall. Participants, please follow the time. The presentation time is 8 minutes and 2 minutes for the question answer session. Please strictly follow the timeline. First of all, judges first I invite Alvin MA, Title of the paper: Pollution Control of Industrial Acetic Acid Effluents via Adsorption on Indigenous Low-Cost Adsorbents, Pharynx and Language Isotherm Analysis.
Good morning to one and all. Respected Chair, distinguishable dignities, and fellow researchers. I am Alvin M.A. I am currently doing MSc Chemistry in St. Thomas Autonomous College, Thrissur. And today my topic is pollution control of industrial acetic acid effluents via adsorption on indigenous low-cost adsorbents. And this process has been done with my Dr. Rohini Daske. First of all, I am talking about acetic acid. Acetic acid CH3COOH is the chemical formula, and it's a colorless gas with a pungent smell, and it's used in several industries such as chemical industries, pharmaceuticals, textile, polymer, paints, foods and beverages, and it has several applications in the food industry. It's a major component in the production of vinegar, and it can be used for the microbial decontamination of meat, especially from the preserving the meat from the attack of bacteria and other pathogens, and also for the mild descaling agent in the food industry, especially in the case of stainless steel, from the cleaning of minerals that have been stuck in the surfaces of different metals, and used for the safe packing of food and its storage. And it's also used for the antimicrobial edible food coating agent. The edible coating helps from the attack of its exposure, the exposure of the food to the different gases such as oxygen and other different kind of gases, and used for its preserving and making it edible for a long time. And it has the contamination of the acetic acid in water sources leads to severe health hazards and the environmental impacts. So in this case, adsorption is an easy and eco-friendly method to remove the acetic acid from the water resources. In the adsorption is the process in which the adsorbents get accumulated in the surface of adsorbent, and adsorption offers such an advantage such as higher efficiency, cost effectiveness, simplicity and versatility for the applications like water purification and gas separation. It's a versatile and economical friendly methods used to remove a wide range of contaminants from both the liquids and gases, and it can be applicable for a broad pH range, and its several features such as efficiency, cost effectiveness and environmental friendliness, simplicity, versatility, wide pH operation and selectivity. And we have been selected the activated charcoal as an adsorbent due to its unique properties such as higher surface area and high porous structure, and its chemical stability, chemical reactivity. Due to all these, we have been used it for several range of applications, especially in the water treatment. It's used to removal of the impurities such as chlorine, lead and other volatile organic compounds from the drinking water, making it safe for the drinking purpose. And the next application, soil remediation. For the activated carbon can be used to clean up the contaminated soil by adsorbing pollutants that can be make available the soil for the agricultural activities and the chemical processing. Activated charcoal can be used as catalyst or adsorbent in the various chemical processes such as the production of hydrogen peroxide, and it's also used in the field of cosmetics for the production of face masks and toothpaste, and it's used to treat the digestive issues such as diarrhea and bloating, and it's also used for the air purifications to remove the pollutants. And there are majorly 4 types of activation have been implemented in this activation methods. The first one is the steam activation. The charcoal has been heated with the steam, which used to increase the pores and increase the surface area. And the second one is the chemical activation. Charcoal has been treated with the chemicals such as acid, base or salt, which helps the porous structure, increase in the porous structure and increase in the surface area. And the third method is the microwave activation. Charcoal has been treated with microwave radiation, which increases the pore structure and increase in the surface area. And the fourth one is ultrasonic activation, which has been the charcoal has been treated with the ultrasonic waves, which helps to create more pore structures and increase in the surface area. Majorly, we have been considered two types of adsorption isotherms: Freundlich isotherms for the physis option, which have been implemented in the multi-layer on heterogeneous surfaces, and the next one is the Langmuir adsorption isotherms, which have been implemented in the chemical chemisorption, which has been implemented in the homolayer adsorption in homogeneous surfaces. The major objectives are the activation of the charcoal using water and NaOH, and second one is the adsorption of acetic acid on different activated charcoals, and the third one is the experimental validation of adsorption using both the Freundlich and Langmuir adsorption isotherms, and also the determination and the comparison of experimental constants using the adsorption of acetic acid on activated charcoals. Majorly, we are using three types of activated charcoals. The first activated charcoal is pure activated charcoal. It's powdered charcoal, and the second one is the activated charcoal has been heated with the low medium with occasional stirring and slightly toasting, which has been the heated charcoal has been subjected to cooling and soaked it for 24 hours in the water, and it is filtered using the filter paper and dried the charcoal at 100 degrees Celsius for 3 hours. And the third one is the powdered charcoal has been mixed with NaOH and stirred for 3 hours and filtered using the filter paper and air dried for 24 hours. The dried charcoal washed using the 50 ml of HCl and with the hot water till the filtrate became alkaline. And the charcoal is filtered and dried out for 100 degrees Celsius for 4 hours. And these are the three types of activated charcoals we are subjected to the studies. And the acetic acid solutions are prepared by diluting 6 ml of glacial acetic acid and dilute using the distilled water to 250 ml of solution. And from this solution, the 6 various amounts of solution have been pipetted into the 100 ml flask according 30, 25, 20, 15, 10 and 5 ml and diluted to the 100 ml by adding distilled water, and to each of
7 minutes over.
Each of the solutions 1.5 grams of activated charcoal have been added and continuously for 45 minutes. And after this method, the initial M and the final M are being calculated, and the Y value and log values are being calculated, and in the case of and graph has been plotted. In the Freundlich isotherms, logarithmic has been used to make the Freundlich adsorption isotherms linear, and log C has been plotted in the x-axis and the log Y has been plotted in the y-axis. In the case of Langmuir, the reciprocal has been used to make it linear, and 1 by C has been plotted in the x-axis and 1 by Y has been plotted in the y-axis. In the these are the experimental constants. In the case of charcoal 2, which has been more pore structure, activated charcoal 2 shows more adsorption, and due to the pure charcoal in the first case, its pore structure is very less. So activated charcoal 2 shows maximum adsorption due to the cleaning and washing and its exposure to the heat. Thank you.
Okay, what is the basic difference between this Freundlich and Langmuir adsorption isotherms?
Both Freundlich has been used for the majorly widely used for the physis option, and Langmuir has been widely used for the chemisorption process.
So what is happening here? In this particular case, the acetic acid and charcoal.
Acetic
acid. The adsorbent and adsorbate, what type of interaction you are expecting, whether it is physical or chemical?
In both cases, we have two types of the acetic acid has been adheres into the surface of charcoal?
As per your opinion, if it is physical interaction, you have to only follow the Friedel-Nish method. If there is a chemical interaction, you have to follow Langmuir. Here you have undergone both the studies. That means they are undergoing at the same time physical and chemical.
Yes. Don't aware of that.
Then the other question is, you have activated the charcoal in 3 methods. The third method, you have washed it with NaOH, then neutralized with HCl, and again the material is becoming, just to go to that slide. Slightly,
alkaline.
it becomes slightly alkaline. Yeah. Charcoal is filtered till the filtrate became slightly alkaline. Okay, that means your charcoal is slightly alkaline. Now you are titrating it with NaOH. Firstly, you are adding it to acetic acid. So if it is alkaline, naturally that alkaline content will neutralize small amount of acetic acid. So naturally it will affect the value. You are adding acetic acid and your adsorbent is slightly alkaline. Then naturally some of the acetic acid will get neutralized by that alkaline nature of NaOH. Again you are titrating with NaOH. So naturally the results we can't, when compared with the charcoal 2. Normally as per your information, it is inferior properties are exhibited by the charcoal 3 only because of it is already containing alkali content. Yes. Why you are washing with it NaOH and making the material slightly alkaline? What is the purpose of washing with NaOH?
We had 3 types of reactions for the experiment. Evaluation of 3 different kinds of charcoal.
So you have discussed about formation of pores in charcoal. So how pores are formed while treating a charcoal? It's a reason for forming the pores. Creation of pore.
Creation of pores are majorly for the absorption of charcoal.
How these pores are created?
Created by the washing and subjecting to heat.
Washing a substance does not create pores. വാഷ് ചെയ്തുകൊണ്ട് മാത്രം ക്രിയേറ്റ് ആവുമോ? ചാർക്കോൾ വാഷ് ചെയ്താൽ പോർ ക്രിയേറ്റ് ആവുമോ? I have another doubt that charcoal is heated in the second method, preparation of charcoal, activated charcoal using heating. Yes. So if we heating charcoal, does it produce any gases or extra gases?
No.
Does it have a chemical reaction going on while heating?
During the heating?
During heating process?
Gases have been formed.
Gases are formed. So there's a chemical reaction while heating this charcoal that changes its properties, physical and chemical properties.
In the case of second charcoal, it increases its surface area expansion. It contributes to the increase in the surface area of second charcoal.
So activated charcoal is heated to increase the surface area.
Increase the surface area and increasing the chemical stability along with the porous structure has to be increased.
Normally, I think porous charcoal is stable in the environmental temperature. If you are heating, it becomes unstable. Does it become unstable?
Unstable by heating?
Heat ചെയ്യുമ്പോൾ അൺസ്റ്റേബിൾ ആവാനുള്ള പോസിബിലിറ്റി ഉണ്ടോ? ഇല്ല. അപ്പോൾ ഗ്യാസസ് ഇവോൾവ് ചെയ്യുന്നത് എവിടെ നിന്നാണ്? കെമിക്കൽ റിയാക്ഷൻ നടന്നിട്ടല്ലേ? അപ്പോൾ ആക്യുറേറ്റ് ചാർക്കോൾ എന്നുള്ള പ്രോപ്പർട്ടി പോവില്ലേ? പ്രോപ്പർട്ടി ചേഞ്ച് വരും. ചേഞ്ച് വരുമോ?
You know what is the purpose of heating charcoal? What do you mean by activation? How you are activating charcoal? That's the basic idea. The thing is, the charcoal which you have purchased will contain already some adsorbers gets adsorbed over it. In order to desorb them, we are heating so that the charcoal surface will be fresh. Then we are adding to acetic acid. That is the purpose of heating.
But the pure charcoal will contain some type
of during packing, some other gases may get adsorbed over its surface. In order to eliminate those adsorbed gases, we are heating it. So desorption will take place so that the surface of the charcoal will be.
Thank you, Alvin. One announcement. Those who are not registered yet, go to the registration desk in front of the Kavi Pratibha hall. Registration will be closed at 11:30. We are circulating attendance sheet. Please make sure you mark your attendance. Thank you. Next, I invite Adira Vijay on the topic, title of paper, Study on Green Energy Adoption and Sustainable Development Practices in Coimbatore for a Low Carbon Economy. Adira Vijay. Next, Lina Joseph. Participants, next one, Ruth Maria Williams, and next is Sandra Joy. Please ensure they are present in this hall. Sandra Joy. Okay, thank you.
Good morning, everyone. I'm Lina Joseph, currently pursuing MSc Chemistry in St. Thomas College. I'm here to present on the topic phytochemical analysis of alcoholic and aqueous extract of some domestic plant leaves under the guidance of Sri Aji CV. Plants contain many chemical compounds which are useful in medicine and other applications. A qualitative phytochemical test can be used to detect the presence of alkaloids, saponins, flavonoids, glycosides, and many other phenolic compounds as well. 4 different varieties of plants were used here. The first variety was Codium variegatum. Codium variegatum, also known as croton or garden croton, has various uses including ornamental, medicinal, and air purification, with traditional uses for treating conditions like diarrhea, stomachache, and skin infections. The next variety used was Tradescantia spathacea. Tradescantia spathacea, also known as oyster plant or mosses in the cradle, is a perennial herb with traditional medicinal uses including treating colds, sore throats, whooping coughs, and fever, as well as being used for anti-inflammatory and antioxidant properties. The next variety was Clerodendrum infortunatum. Is a shrub used in traditional medicine for various ailments including asthma, bronchitis, fever, skin diseases, and epilepsy, with potential anti-inflammatory and anti-diabetic properties. In many traditional practices, the leaves and roots are widely used as anti-hyperglycemic. The next variety used was Maranta arundinacea. It is a tropical tuber primarily used as a source of starch for thickening food and is sometimes used in baking and cooking as well as in some traditional medicinal applications. A typical extraction process may contain the following steps: collection and authentication of plant material and drying, size reduction, extraction, filtration. Here, alcoholic and aqueous extracts of each domestic plant leaf are prepared and tested. The phytochemical analysis for the first phytochemical analyzed was alkaloids. The test used was Mayer's test, where a few milliliters of the plant extract, 2 drops of Mayer's reagent was added along the sides of the test tube. Appearance of a white creamy precipitate indicated the presence of alkaloids. The next phytochemical used was analyzed was carbohydrates, where we used the Felling's test. To the extract, Felling solution was added and heated on a water bath. The formation of a red precipitate indicated the presence of reducing sugars. The next test was saponification test to detect fixed oils and fats. To a small quantity of the extract, a few drops of 0.5 normal alcoholic potassium hydroxide solution is added, followed by a drop of phenolphthalein. The mixture is then heated on a water bath for 2 hours. Formation of soap or partial neutralization of alkali indicated the presence of fixed oils and fats. The next phytochemical detected was glycosides. 50 mg of the extract is hydrolyzed with concentrated hydrochloric acid for 2 hours on a water bath, filtered, and the hydrolysate is subjected to Legal's test. In Legal's test, 50 ml of the extract is dissolved in pyridine. Sodium nitroprusside solution is added and made alkaline using 10% sodium hydroxide. Pink color indicates the presence of glycosides. The next phytochemical detected was saponins. The extract is diluted with distilled water and made up to 20 milliliter. The suspension is then shaken on a graduated cylinder for 15 minutes. A 2 cm layer of foam indicated the presence of saponins. Amino acids, 2 drops of ninhydrin solution was added to 2 milliliter of aqueous filtrate. Appearance of purple color indicated the presence of amino acids. The next phytochemical used detected was terpenoids. To a mixture of 5 milliliter of the extract and 2 milliliter of chloroform, 3 milliliter of concentrated sulfuric acid was added along the sides of the test tube and shaken well. A reddish brown coloration at interface of 2 layers indicated the presence of terpenoids. Proteins, biuret test was used here. 2 milliliter of the extract is treated with 1 drop of 2% copper sulfate solution. 1 milliliter of ethanol is added, followed by excess of potassium hydroxide pellets. Pink color ethanolic layer indicated the presence of proteins. The next phytochemical was phenolic compounds. Lead acetate test was used. The extract is dissolved in distilled water, and to this 3 milliliter of 10% lead acetate solution is added. A bulky white precipitate indicated the presence of phenolic compounds. The next phytochemical detected was flavonoids, where dilute NaOH was added to 1 to 2 milliliter of the extract. A yellow intense color indicated the presence of flavonoids. A few drops of dilute acid was added. Colorlessness indicated the presence of flavonoids again. These were some of the tests that we did. Moving on to the results, alcoholic extracts of Codium variegatum showed positive results for alkaloids, glycosides, fixed oils and fats, terpenoids, proteins, and amino acids, while its aqueous extract showed positive tests for alkaloids, carbohydrates, terpenoids, proteins, phenolic compounds, amino acids, and flavonoids. While the alcoholic extract of Trediscanthia spatacea showed positive results for terpenoids, proteins, and amino acids, while the aqueous extract showed positive results for fixed oils and fats, terpenoids, proteins, phenolic compounds, flavonoids, and amino acids. The alcoholic extracts of Clerodendrum infortunatum showed positive results for saponins, proteins, phenolic compounds, and amino acids, while the aqueous extract showed positive results for glycosides, proteins, phenolic compounds, and amino acids. The alcoholic extracts of Maranta arundinacea showed positive results for fixed oils and fats, carbohydrates, saponins, proteins, phenolic compounds, and amino acids, while its aqueous extracts showed positive results for carbohydrates, saponins, proteins, phenolic compounds, and amino acids. From the above studies, it was found that these extracts are rich in many phytochemicals such as alkaloids, phenolic compounds, flavonoids, glycosides, proteins, carbohydrates, amino acids, saponins, and terpenoids. Results indicate that the leaves are a rich source of phytochemicals with potential medicinal properties. The variation in phytochemical composition between the alcoholic and aqueous extracts highlights the importance of solvent selection in extracting bioactive compounds. Overall, the study provides valuable insights into the phytochemical profile of leaves and paves way for further research into therapeutic potential. The phytochemicals extracted from the leaves can be used to develop new drugs or dietary supplements for various diseases such as cancer, diabetes, and cardiovascular disorders. The bioactive compounds can be used in the development of skin care and hair care products such as anti-aging creams, sunscreens, and shampoos. The extracts can be used as natural preservatives, flavor enhancers, and colorants in fruit products. The study can be extended to investigate the in vivo and in vitro biological activities of the extract such as antioxidant and anti-inflammatory and antimicrobial activities. Thank you.
What are the importance of studying about the amino acids and proteins in plants? Any variation or differences seen between these tests, phytochemical tests?
Of amino acids and proteins. At first, there was some differences in not these varieties, but other varieties where amino acids did show negative results. And proteins showed negative results while amino acids showed positive results. We concluded that it must be because of the mono amino acids would have influence there and peptide bonds weren't there. Therefore, amino acids only the amino acids showed positive results and proteins didn't.
What are the significance of doing such a this type of research work?
a lot of the medicinal applications as well as cosmetic applications are seen. For example, for flavonoids, there are cosmetic potentials, more cosmetic applications that are possible, as well as for alkaloids as well, where it is used. Many alkaloids like morphins, nicotine, and many things are still being used as a drug as well.
Okay. Lina, you have performed qualitative phytochemical studies of how many species? 3.
4.
4. Okay. These are the general tests used for the qualitative analysis of components present in the plant extracts. And these components are present in all types of plant species. What is the significance of your phytochemical study? Alkaloids, terpenes, flavonoids, or carbohydrates, etc. etc. These are all present in almost all plant extracts. The alkaloid may be different, terpenoid may be different. That is the significance of study. If you are focusing on to a particular alkaloid and focused on to its medical implication, that's a very good work. But it's a general study of the presence of alkaloids or terpenoids or flavonoids, etc. Then second thing is in one species you have mentioned that the presence of carbohydrate is not detected. Is there any plant extract without carbohydrate?
Carbohydrate, which species?
Let's go to the slide. Back.
Carbohydrate.
Along the carbohydrate, there are
2 varieties which doesn't show carbohydrates.
Yeah. If it is a living species, naturally it will contain carbohydrate. So it is found to be negative. Oils and fats. Then alkaloids. Alkaloids are the crucial components present in the plant for their protection, but it is also absent. Okay.
Why have you done 2 experiments on aqueous solution and also in alcoholic solutions?
The solvent's polarity difference may give a wide range of bioactive compounds. The polarity difference can make the phytochemicals have a wide range of, can
മലയാളത്തിൽ പറഞ്ഞോളൂല്ലേ മലയാളത്തിലായാലും കുഴപ്പമില്ല
polarity difference കാരണം നമുക്ക് കൂടുതൽ ഫൈറ്റോകെമിക്കൽസിനെ ഡിറ്റക്ട് ചെയ്യാൻ പറ്റും. ഫൈറ്റോകെമിക്കൽസിന്റെ പൊളാരിറ്റി ഡിഫറൻസിന്റെ അനുസരിച്ച് അത് ഡിഫർ ചെയ്യും രണ്ടിനും.
സോ അത് നമുക്ക് എൻഹാൻസ് ചെയ്യാനാണ്. എന്തെങ്കിലും സൈലൻ്റ് ആയിട്ടുള്ള പാരാമീറ്റേഴ്സ് ഉണ്ടെങ്കിൽ എൻഹാൻസ് ചെയ്യാനാണ് നമ്മൾ ആൽക്കഹോളിക് സൊല്യൂഷനിൽ. സോ നമ്മൾ ഇപ്പോൾ ഫസ്റ്റ് സാമ്പിൾ നോക്കുകയാണെങ്കിൽ കാർബോഹൈഡ്രേറ്റ് അക്വ സൊല്യൂഷനിൽ പ്രസൻ്റ് ആയിരുന്നു. അത് ആൽക്കഹോളിക് സൊല്യൂഷൻ ഇങ്ങനെ ആബ്സെൻ്റ് ആവുന്നത്. അതുപോലെ ഫാറ്റ്സ് ആൻഡ് ഓയിൽസ് അക്വ സൊല്യൂഷനിൽ ആബ്സെൻ്റ് ആയത് ഹൗ ഇറ്റ് ബിക്കം പ്രസൻറ്റ് ഇൻ ദ ആൽക്കഹോളിക് സൊല്യൂഷൻ.
ചിലപ്പോൾ അത് മറ്റേ ബയോ ആക്റ്റീവ് ഫിക്സ്ഡ് ഓയിൽസ് ആൻഡ് ഫാറ്റ്സ് ആൽക്കഹോളിക്കിൽ കുറച്ചും കൂടി പൊളാരിറ്റി ഒരു ഇത് കാരണം
അപ്പോൾ അവിടെ ഒരു കെമിക്കൽ റിയാക്ഷൻ നടന്നിട്ടുണ്ടാവില്ലേ? അങ്ങനെയാണെങ്കിൽ നമുക്ക് ടെസ്റ്റ് റിസൾട്ടിൽ പോസിറ്റീവായിട്ടത് എടുക്കാൻ പറ്റുമോ?
Not sure, ma'am.
Okay. ഇത് ഈ സ്റ്റഡീസിന് നമുക്ക് എത്ര പെർസെൻറ്റേജ് ഓഫ് ഫാറ്റ്സ് ആൻഡ് ഓയിൽസ് അങ്ങനെയൊന്നും സ്റ്റഡി ചെയ്തിട്ടുണ്ട്?
ക്വാണ്ടിറ്റേറ്റീവായിട്ട് നോക്കിയിട്ടുണ്ടായിരുന്നില്ല.
നോക്കിയില്ല. അപ്പോൾ നമുക്കിത് റെഫർ ചെയ്തിട്ട് ഇന്നതിന് ഉപയോഗിക്കാം എന്നുള്ളൊരു ഇൻഫ്ലുവൻസ് ഒന്നും കിട്ടിയിട്ടില്ല.
ഇല്ല, നമ്മൾ യൂഷ്വൽ കാൽക്കുലേറ്റ്
പ്രസൻസ് മാത്രമേ ടെസ്റ്റ് ചെയ്തിട്ടുള്ളൂ.
മാത്രമേ ഡിറ്റക്ട് ചെയ്തിട്ടുള്ളൂ.
ഓക്കെ, താങ്ക് യു.
Thank you.
Thank you, Lina. Next, we have Ruth Maria Williams Title of paper: Preparation of coconut shell biochar and its applications in removal of zinc ion from aqueous medium.
A warm good morning to all. I am Ruth Maria Williams, currently pursuing MSc Chemistry, St. Thomas College, Thrissur. Today I am here to present my topic titled Preparation of Coconut Shell Biochar and its application in the removal of Zn2 plus ion from aqueous medium. As the title says, our objective is to prepare coconut shell biochar and analyzing its capacity in the removal of Zn2 plus ion. Biochar is a black, highly porous, lightweight, fine-grained powder. It is having larger surface area. 70% of its composition is carbon, and the remaining remaining percentage consists of nitrogen, hydrogen, oxygen, and other elements. Biochar have tremendous potential in removing heavy metal ion. It is a special type of charcoal produced by burning organic material in the absence of oxygen. It is the stable form and helps to reduce contamination. From the references, this is the biochar structure. It is predominantly amorphous with regions of local crystalline organization with conjugated aromatic compound. And here the synthesized biochar is characterized using FTIR. And in the first procedure, we are preparing coconut shell biochar. And here grind the coconut shell into small pieces, and we are heating it in the muffle furnace at 600 degrees Celsius for 1 hour, and the sample is cooled in the furnace to prevent oxidation, and then the sample is stored in the desiccator to prevent moisture. Next is the preparation of zinc sulfate solution. Initially, EDTA is standardized using magnesium sulfate solution, and the amount of zinc ion in the whole of solution can be estimated by titrating 20 ml of the solution against standardized EDTA. Buffer and erichrome black tea indicator is used before the titration. And next is the treatment of zinc sulfate with biochar. 0.2 gram of biochar is taken in 300 ml beaker, and 20 ml of estimated zinc sulfate solution is added into each. The first beaker is kept in rest for 15 minutes, and the second solution is stirred with a glass rod for 15 minutes, and the third solution is stirred with a magnetic stirrer for 15 minutes. After that, each of the solution is centrifuged for 2 minutes. The filtrate of each solution is taken in 3 conical flasks and titrated against standardized EDTA, and titer values are observed. From the FTIR spectra of synthesized biochar, we can see the functional group present in the biochar. And next is the removal of Zn2 plus ions using biochar. Here, before the contact with the biochar, the concentration of zinc was 0.025 molar, and after the contact, where the solution which is kept in rest has absorbed 73.2% of zinc, where the solution which was stirred with a glass rod has absorbed 70.6%, and where the solution which was kept in the magnetic stirrer has absorbed up to 64%. And this is the FTIR of the biochar before and after the removal. And here we can see that the structure of the biochar is similar in both cases, and from that we can analyze that it has not significantly affected on the structure of the biochar. And here in our case, pore filling effect and electrostatic interactions are the major cause of adsorption, and it is also observed that with the increase in the speed of stirring, our adsorption has slightly decreased, and this is due to electrostatic repulsion that it experiences, because from the studies it shows that biochar is having a positively charged pore. And here we have prepared coconut shell biochar, and we have analyzed its capacity in removing zinc ion using complexometric titration. Thank you.
So you have prepared biochar using coconut shell.
Yes, sir.
What is the difference between the obtained product from charcoal? What is charcoal?
Charcoal is burned in the presence of oxygen, whereas the biochar is synthesized in the absence of oxygen, that is pyrolysis.
You have heated it in a muffled furnace.
Yes.
It contains oxygen also. What is the difference between the product obtained?
It is
Both
more. Charcoal is in the presence, and here we are doing in the
As
absence
per your
of oxygen.
procedure, you have heated it in a muffled furnace.
Muffled furnace, yes, sir.
The chamber contains oxygen.
Limited supply of oxygen.
How you have supplied limited?
Already there is an oxygen, so limited supply.
Okay. Second thing is you have studied the absorption capacity of that obtained biochar.
Yeah.
Using how much amount it gets absorbed zinc.
Yes, sir.
Zinc ions on surface. And one of your slides, just to go back. Again, yeah, that's the result, absorption result. Yeah. Normally, we are also performing such absorption studies in our physical chemistry lab. So, normally what we are doing is we are making, we are shaking, for getting better absorption, the adsorbent and adsorbate should be thoroughly mixed well. For that we are placed it in a shaker. So, but in your study, when you are going stirring using a magnetic stirrer, the extent of adsorption is found to be less. You have to say that only 64% gets adsorbed.
Yes, sir.
So it is contradictory to the existing scientific results.
In the references, it says that biochar is a positively charged. So as the force of stirring increases, it gets repels, and the percentage of adsorption decreases.
It's not clear for me. That means that extent of adsorption depends upon the extent of stirring.
Stirring, yes, sir.
That is the existing scientific conclusion, and that is we are following in your PG lab also. But in your result, if you are giving stirring, the extent of adsorption is getting reduced. Once it is get adsorbed with the continuing stirring, it will not detach from the adsorbent surface.
Ruth, why do you select zinc ion?
Ma'am, we have already experimented with the chromium 6+ ion, but that was biochar was not effectively absorbing chromium when compared to zinc. So we chose zinc for a project.
There are more metal ions.
We have used two of the ions, zinc and chromium.
Either it's used to charge 2+ charge or something at positivity electrochemical series. അതുകൊണ്ടാണോ ഇലക്ട്രോകെമിക്കൽ സീരീസിൽ ഇത്ര റേഞ്ചിൽ വന്നാലാണോ ഡിസ്പ്ലേസ്മെൻറ്റ് നടക്കുക അങ്ങനെ എന്തെങ്കിലും നോക്കിയിട്ടാണോ?
അല്ല.
ഇത് വൈ ഇറ്റ്സ് കോൾഡ് എ ബയോചാർ?
Sorry, ma'am?
Why it's called biochar?
That
Now, how do you measure the presence of concentration of zinc ions? In this slide, you are measuring the concentration of zinc ions as 0.25 molar.
That is using complexometric titration. We can know the concentration of zinc.
Actually, zinc is present in the solution itself.
Yes. In this ZnSO4 solution, zinc is present.
അപ്പം ടൈട്രേറ്റ് ചെയ്യുമ്പോഴും സിങ്ക് അവിടെ തന്നെ ഉണ്ടല്ലോ, അബ്സോർബ് ചെയ്തിട്ടുണ്ടല്ലോ, adsorb അല്ലേ ചെയ്തിരിക്കുന്നത്. So zinc is present in the solution itself.
It is adsorbed by the biochar.
Are you filtering it?
And that filtrate, after the adsorption, that filtrate is again titrated with EDTA, standardized EDTA.
Okay. Thank you.
Thank you, ma'am. Thank you, sir.
Thank you.
Thank you, Ruth Maria Williams. Next, we have Sandra Joy. Title of paper: Synthesis and Applications of Poly N-methyl aniline for Removal of Chromium from Water.
Good morning to one and all present here. Myself, Sandra Joy, MSc Chemistry student of St. Thomas College, Thrissur. Today I am here to present the project entitled Synthesis and Application of Poly N-methyl aniline for the Removal of Chromium-6 from Water. I conducted this project under the guidance of Dr. Jency Thomas, Associate Professor of St. Thomas College, along with my team members Abhinav KR, Gogulnath TR, Amrita DS. I express my sincere gratitude to all of them. Occurrence of chromium in natural water is observed. The concentration up to 2 mg per liter is accepted, but in some places it was found that up to 120 mg per liter was measured. Now it is very toxic and dangerous to living organisms. How does it happen? Industries release the wastewater without improper treatment. Also leakage and poor storage is the reason. How can we make a solution for this? There are several treatment methods for this wastewater, that is coagulation followed by precipitation filtration, adsorption onto different media, ion exchange, membrane technology and electrodialysis, biological removal. But all these have some or other limitations, and there is no such process effective and cost effective methods for the treatment of the wastewater. So we introduced poly N-methyl aniline for the removal of chromium-6 from water. Our objectives of the project is synthesis of poly N-methyl aniline, characterization of the synthesized poly N-methyl aniline, removal of chromium-6 from contaminated water, and elucidating the mechanism for the removal. In the synthesis, we synthesized polymer by utilizing N-methyl aniline in the presence of HCl. It was stirred for 15 minutes and the solution was formed. And another solution of ammonium persulfate with water was stirred for 15 minutes. Both the solutions were mixed together and stirred for 2 hours. A dark green solution was obtained, which was filtered, washed and dried. Thus, the polymer was synthesized. The synthesized polymer was expected to have a benzenoid ring and a quinonoid ring, also having a positively charged nitrogen balanced with chloride ions. And this structure shows that it has a half oxidized emeraldine form. The characterization was carried on by Fourier transform infrared spectroscopy, which showed the stretching of methyl group at 2312 cm inverse, carbon-carbon double bond stretching of benzenoid ring at 1487 cm inverse, carbon-carbon double bond stretching of quinonoid ring at 1563 cm inverse, and the carbon-nitrogen stretching of aromatic tertiary amines at 1300 cm inverse. The powder XRD pattern was also studied. It showed low degree of crystallinity because of the broad peaks observed, and this also goes with the same image as we obtained an amorphous solid. Now moving on to chromium removal studies, a definite amount of the polymer was weighed and added to 2 ppm 10 milliliter of potassium dichromate solution, stirred for 60 minutes and filtered. We added 0.5 ml of 10% sulfuric acid along with 0.5 ml of diphenyl carbamide to the filtrate, and the UV visible spectra was recorded. This is a UV visible spectra of the bare 2 ppm chromium solution, and after the addition of polymer, it is evident from the spectra that the absorbance is very low in case after the addition of the polymer, which shows the chromium has been effectively removed by the polymer. We studied the effect of amount of poly N-methyl aniline, that is, we varied the amount of the polymer from 0.01 grams to the 0.1 grams with the same concentration and same pH measures, and it was stirred for the same time, that is 60 minutes, and the maximum chromium removal was obtained with 0.1 grams. Stirring time was also varied, and we found that maximum removal of chromium 6 was obtained at 60 minutes. With this 0.1 gram of polymer in the 10 ml of 2 ppm chromium solution with varied pH, we found that the maximum removal is optimum in 1 to 5 pH. Temperature studies was carried and the removal of chromium 6 was possible between 5 to 60 degrees Celsius. Reusability of the polymer was also checked. The same amount, the 0.1 gram of polymer which was used at first showed maximum removal. The same polymer was utilized till 9th cycle, and we found that from the UV visible spectroscopy that it could be reused up to 9th cycle. The mechanism of the chromium 6 removal, the emeraldine form of the formed polymer N-methyl aniline contains a positively charged nitrogen which is balanced by the negatively charged chlorine ions. On the approach of the dichromate anions, the oxygen and the nitrogen becomes electrostatically interacted, and this is how they remove the polymer removes the dichromate ions. So as more the binding sites, more the amount of chromium is removed. Conclusions: as the amount of adsorbent increases, the adsorption of the chromium 6 increases. Also, stirring time has a great impact because the period of contact between the chromium 6 and the polymer, as the time period increases, more amount of chromium is removed from the water. Also, the electrostatic interaction between the dichromate anions and the polymer was responsible for the removal of chromium 6 species. Reusability tests was carried and was found that it could be reused up to the 9th cycle. The optimum pH range for the usage of the polymer is 1 to 5, and the optimum temperature range is 5 to 60 degrees Celsius. Future prospects: the absorption kinetics can also be studied of this polymer. The removal is successful as we have studied. Relevance to the society: we know chromium 6 is very much carcinogenic, so it requires to be removed from the wastewater that is being emitted from the industries. So for that, this polymer can be used in industrialized, so can be used for the removal of the chromium 6 from water to improve the quality of the contaminated water samples. Therefore, it helps in recycling the wastewater. Thank you.
Well, Sangara. So you have mentioned that chromium 6 has several hazardous effects on our body. What about chromium 3?
Chromium 3 is also toxic, but in low concentration, another way we can say that chromium 3 is also good as a nutrient for our body. In higher concentrations, it is toxic, but still compared to chromium 3, comparing chromium 3 and chromium 6 is more toxic. That's
Again,
why we
you have mentioned that in some 4 to 5 cities in India, the concentration of chromium ion, chromium 6 plus in those cities are very high. What is the reason for that?
Mainly chromium is used in many industries such as paint industries, dye, textile, as well as electroplating industries and all. And these industries just expel the wastewater without treatment. And maybe also due to poor storage and leakage can also be the reason. So in order to improve the quality of the contaminated water, we cannot, I don't think we can completely 100% remove chromium, but about 90% if the removal is possible, it's effective and helpful to human society. So that's what we were trying to study. So these in those mainly North Indian states, most of the industries are located, and that's why the rivers are getting contaminated so much.
Just go back and the slide regarding the pH of the pH studies. Okay. Here you are using pH starting from 1 to 5. Maximum removal efficiency shown by which is solution?
pH 1 to 5, 1, 3 and 5 can also is acceptable.
All the three pH are giving the same result.
Yes, we studied it and it's giving the same result.
Have you gone to the alkaline range?
No, sir.
See, as per your mechanism suggested by you, that there is the removal is by means of interaction between the adsorbent and adsorbate, electrostatic type of interaction.
Yes, sir.
So, can this compound can be used to remove any anionic species from water? If it is purely electrostatic, then this material can be used to remove any anionic species from water.
We have not studied about it in such depth. This is we have just elucidated it. Maybe studying about the kinetics, we could understand it whether it is.
Have you taken
true
the
or not.
IR of this compound after adding chromium?
No, sir.
Only that.
Only of the
based on that
synthesized-
you can say that there is an interaction between this nitrogen and oxygen.
Yes, we took the IR characterization of only of the polymer, not after the usage of it.
Okay.
Sandra, you have discussed you are reusing this polymer. So how you are separating this polymer and chromium compound? After adsorption, how you are separating this chromium?
The chromium is adsorbed to the polymer, and we filter it, and we get the polymer as a precipitate. The polymer contains the chromium, and we are reusing it again. That's what I was mentioning. Yes.
So polymer with chromium is used.
Yeah, used again and again, and up to 9th cycle it's showing the removal. But efficiency would be low, but still we can use it again.
So we are using the polymer with the chromium. Is it toxic?
The polymer is toxic, but studies have shown, as I've read, N-methyl aniline is very toxic, but poly-N-methyl aniline is toxic or not, it's not studied so much, so we can go through it also.
So we are using aniline, which is toxic element, to remove chromium, which is another toxic element from water.
But we have polymerized it.
Okay. So again, water contains chromium and other elements also.
Water
Contains chromium as well as other elements only. Is there a possibility that chromium may be misplaced by another elements and chromium filtration may be ineffective?
I think that's what sir asked before.
So have you tried with water content?
That we have not checked. We have just tried only with the solution that is containing chromium. We did not study whether other anions are getting interfered or not. There's a future aspect of it.
And what's the percentage of chromium content in our water? Normal water.
Normal drinking water, we expect it to be fresh water. So up to 2 milligram per liter, it is widely accepted range, but more than it, it is toxic, and that I don't know.
Okay, thank you.
2 milligram per liter.
Okay, thank you, Sandra.
Thank you, Sandra. The presentation is over. Thank you, judges and participants. Next section will begin shortly. Dear participants, the certificates will distributed in valedictory function. Please be there at Medley Court Hall at 12:45 p.m.
Participants for the next session, Ms. Sharanya SS, Ms. Sona Manoj, Mr. Vimal Chako P. Please report at the mic point immediately. Good morning, everybody. As we all know, we are gathered here on the second day of the two-day international conference on substantial and indigenous technologies and cultures, ICIT 2025, jointly organized by the R&D Cell, St. Thomas College, IIC, IEDC, IKS and IQAC. We'll be continuing with the offline paper presentation, and the thrust area for the session would be Indigenous Medical System and Healthcare. Let us invite our eminent panel of judges. We have with us Dr. Vimala K. John, Associate Professor, Department of Zoology, and Dr. Deepa Francis, Assistant Professor, Department of Psychology. We welcome both of you. So let me just read the guidelines for the paper presentation. All the participants, please note and be careful about it. Each participant will be allotted 8 minutes for the presentation and 2 minutes for a Q&A session. Warning bell will be at 7 minutes. Kindly wind up the presentation in 1 minute. Exceeding the time limit may lead to the deduction of marks. Judging criteria include extended abstracts, content and research quality, and presentation and delivery. Decision of the judges will be final. I think we are okay to go with the presentations. First, let me invite, with the consent of the judges, let me invite our first presenter for the day, Ms. Sharanya S.S., and her paper is titled Hybrid Biofunctional Coated Substrates for Enhancing Neuronal Growth.
Good morning everyone, I am Sharanya. I am a research scholar from Sri Chitrathunal Institute for Biomedical Science and Technology Wing. I would like to present my topic entitled The Hybrid Biofunctional Coated Substrate for the Enhanced Peripheral Nerve Repair. To start, why do we need the nerve guide conduit? The nerve play an important role in our day-to-day life. Any damage to the nerve, they can compromise the quality life of the patient, even though the peripheral nerve have their own capacity to regenerate itself. But their regeneration hampers some cases such as the segmental defect or the compression defect. In these cases, the graft is required. The most commonly used grafting technique is called autograft, that is the nerve harvesting from their own body, but it shows some drawbacks such as the second surgery, which result in the donor site mobility, scarring and neuroma formation. So such cases, the attention is more given to the synthetic nerve guide conduit. Actually, it is a tubular structure which is made up of the natural and synthetic conduits, which is designed to have the peripheral nerve repair application. Currently, the synthetic nerve guide conduit is have the great potentiality in the market. Then given on the right side are the currently available the guide synthetic conduits are available on the market, but it shows some drawbacks such as all the conduits have become the single hollow tubular structures, so they do not mimic the extracellular matrix, and it is only applicable for the short defect gap. So how to resolve this problem? This is done by designing the cell-derived extracellular matrix coated on the neurocompatible substrate. Why we are using the cell-derived extracellular matrix? Because the cell-derived extracellular matrix is one of the most important factors which provide the cell enhancement, proliferation and the migrational property of the material. So, but they are showing the several challenges for the designing of such creation, that is the material selection, biocompatibility, the complicity, the cell-material interaction and cell survival rate. So, in our studies, we are choosing our base material become polycaprolactone because it is biocompatible, biodegradable, FDA-approved material which is widely used for various biomedical applications. So we are preparing the PCL sheet through the technique called the solvent casting technique. The PCL bead is dissolved in the dichloromethane and the solvent evaporate and we obtain the PCL sheet. But it shows some drawbacks such as the hydrophobic nature of the material. That's the reason we again modifying the PCL which is blending with another polymer called the PVP. Then we are obtaining the technique called the solvent casting technique. Then after the modification, we checking all parameters and confirming that these materials are neurocompatible. After we convert the modification of neurocompatible substrate into the hybrid biofunctionalized substrate using the adipose-derived mesenchymal stem cell. Here what we did was the mesenchymal stem cell which is incorporated into the substrate and forming the biofunctionalized extracellular matrix-coated substrate which facilitate the cell homing, proliferation and thereby enhancing the bioactivity upon the implantation. So these are the schematic overview protocol of isolation of adipose-derived mesenchymal stem cell. We just taking the animal from the Vista rat at the age of 4 months. Then after the isolation, we are checking the more micrographic images of adipose-derived mesenchymal stem cell in various passages. Here we can see that from P0 to P3 passages, the cell changes its morphology into the spindle shape. After the P3 passages, the cell is used for the in vitro analysis. Before moving to the in vitro study, so first we are analyzing the isolated cells become the mesenchymal stem cell. So we are following the International Society for the Cellular Guidelines. So first we checking the adhesion property of the material. So we confirming that the cell showing the good adhesion as well as it is showing the polygonal morphology. After we checking the positive and negative marker expression of the adipose-derived mesenchymal stem cell by using the flow cytometry, here we confirming that the CD19 showing the 83.74% rather than the CD45 only 0.3% against the unstained sample. So next we checking the trilineage differentiation to confirming that it is showing both the lineages such as the osteogenic, adipogenic and the chondrogenic differentiation. After confirming that these isolated cells become the mesenchymal stem cell. Then after we just modifying the cell-derived extracellular matrix which is coated on the substrate, first we seeded the cell on the material, they producing extracellular matrix production. After moving the decellularization process, moving the freeze-thawing technique, then we obtain the cell-derived extracellular matrix which is moving for the decellularization techniques. So once the modification completed, we checking the physicochemical as well as the in vitro cytocompatibility analysis. First we checking the morphological analysis by using the SEM. Here we can see that the before decellularization, the cells are highly attached on the matrix. Then after decellularization, the cells are no longer visible and the surface is showing the fibrillar architecture. Next, we confirming the hydrophilic nature of the modified substrate by using the water contact angle. Here we can see that the water contact angle decreases with the increasing hydrophilic nature of the polymer. So with the help for the cell material attachment and the proliferation. Next, we confirming the modified substrate is attached on the matrix. So we are checking the FTR spectra. So here we can see that the modified substrate contains the presence of amide bond. Then we again checking the purity of the extracellular matrix on the material surface. So here what we did was we are just staining with the DAPI staining. So before decellularization the cell is adhered. So that's the reason we can see the nuclear staining visible on the before decellularization technique. Then after decellularization there is no debris are the seen. That's the reason there is no signaling is visible on the matrix. Next we are moving to the collagen presence by using the serious red staining because the extracellular matrix contain the main component become the collagen. So we are checking after decellularization. Here we can see that the presence of red staining indicating the collagen presence. So once the modification completed, it is moving to the in vitro cytocompatibility analysis by using the NDA saline. So the cytotoxic analysis by using the qualitative as well as the quantitative analysis. Here the qualitative analysis by using the direct contact images. Here we can see that the cells are viable on the material and there is no morphological evidence of any cell death or the toxicity in any of the sample. So this study is confirming that the cell retained its differentiation morphology as well as the good adhesion of the cell culture even after the 48 hours of exposure. Next we are moving to the quantitative analysis by using the Alamar assay. Here we can see that the cells are viable on the material surface. When compared with the control group, their viability become very higher. Next we move to the cell live data assay by using the qualitative staining. Here we are using two stain. One is called the acridine orange and the second stain become ethidium bromide. The acridine orange stains the live cells in green colored images and ethidium bromide stains the dead cells in red colored images. Here we can see that the modified substrate contains the presence of viable cells are on the matrix and it become highly adhered on the matrix surface. Next we move into the cytoskeletal staining of the cell-derived biofunctionalized matrix on the cell surface. Here we are using the rhodamin phalloidin as well as the DAPI staining. Rhodamin phalloidin stains the cytoskeleton as well as the DAPI stains the nucleus. Here we can see that here the DAPI is in intact position and it also showing the good adhesion property of the cell on the material. Next we move to the immunofluorescence staining of the undifferentiated NDA cell on the hybridized matrix surface. Here we can see that here we are using the immunostaining become beta tubulin. Here we can see that cells and it indicating that the distribution and the neurite enhancement on the material matrix. Next, we move into the migrational property of the cell on the substrate, because it is important parameters in case of the neuronal cell line, because it is moving from the proximal region to the distal end. So we are checking the scratch wound assay. So the study is again confirming that after the 48 hours there is no scratch visible on the matrix. So this is confirming that the modified substrate contains the good migration property of the cell towards the scratch region. So in these studies, we successfully concluded that the hybrid cell-derived extracellular matrix biofunctionalized the substrate, which is the promising approaches for peripheral nerve repair, and it are offering the benefit for the synthetic polymers and the cell-derived extracellular matrix, which creating the microenvironment for the nerve regeneration application. And because that cell-derived extracellular matrix providing its ability to support the cell activity, the axonal growth, and it promote the functional recovery of the neuronal cell, which is an alternative to the conventional nerve repair scaffold. So by combining the biological functionality with the structural support, these scaffold improve the chances of the functional nerve regeneration and making them valuable tool for the next generation therapies for the peripheral nerve injury. These are the references. I thank to the director and head of BMT wing in SET MST who are giving me the facilities are provided, and thank to my guide and my team members. They are giving me the valuable support for my entire journey. I thanks to the organizers for they are giving me the valuable presentation over here. Thank you.
The stage is now open for questions.
Congratulations, Sharanya. Your presentation was good. Your words float like a river.
Okay.
And I have a general question. What was the most difficult part of this current research?
Yeah, because these nerve guide conduits are currently available in market, because all the nerve guide conduits become hollow tubular structures. So they cannot mimic the extracellular matrix. That is the reason we just modifying the extracellular matrix coded on their substrate and also providing the channeling cues. I am not mentioning in channeling section here. I am only modification part is mentioning here.
Congratulations,
Thank you, ma'am.
Sharanya. I have some more questions from your topic. Why the substrate PCL PVP is taken for this study?
Yeah, because in the nerve guide conduit application, we are requiring the following parameters such as the biodegradation and hydrophilic nature, porosity. That's the reason we are choosing the PCL and PVP blending system, because it provides the hydrophilic nature as well as the porosity.
So the relevance of the taking this N2SLs to this?
Yeah, N2SL is the neuronal cell line. That is the in vitro studies. We are mainly using the N2SL line to check the cells are how the cells interact with the material surface and what's the cell-friendly nature of the material.
You have checked this dichloromethane toxicity in this study? Dichloromethane toxicity. You have mentioned one term.
Yeah, dichloromethane acts as a solvent. Whenever it is evaporating, there is no presence of dichloromethane. Only the PCL and PVP is existing, because we are checking the degradation and elution studies.
You have studied the cytotoxicity?
Yeah, yes, ma'am. Because after sterilization, we are just moving for the in vitro studies. We are checking all the parameters.
So, can you explain the term neurocompatibility?
Yeah, the cell which is the neuronal cell which is compatible to the material, that is called the neurocompatibility.
What is the process of decellularization process?
Yeah, decellularization is the process in which the entire removal of the cell materials, but cell component are only existing the extracellular matrix. That is called the decellularization process. That is the reason we are checking the DAPI staining to purity of the extracellular matrix only present on the material surface.
In the characterization studies, the water contact angle is constant for all?
No, water contact angle is not constant for all the cases, because in the case of PCL, it is a hydrophobic nature. Then compared with the PCL PVP condition, it becomes decreases in the hydrophilic nature. When additionally we are just modifying with the extracellular matrix, such cases it is compatible with the cell material interaction, approximate the amount into the 60 degree.
Okay. Then what is the relevance of the staining this beta-tubulin immunofluorescence studies?
Yeah, because the immunofluorescence staining we are just mainly using in neuronal cases the beta-tubulin, because it is providing the microtubule architecture and the organization and distribution of the neuronal cell exactly. That's the reason we are just using immunofluorescence staining by using beta-tubulin.
Okay. Okay, Sharanya, you have answered all in proper way. Thank you.
Thank you so much.
All the best.
Thank you, Ms. Sharanya. Up next, we have Ms. Sona Manoj presenting her paper titled
Hello.
Good afternoon, distinguished delegates, honored guests, and lovers of cultural heritage. Welcome back to the International Conference on Sustainable and Indigenous Technologies and Cultures.
We are moving on to a truly magnificent expression of Kerala's living traditions, a performance that embodies the very essence of cultural sustainability and indigenous artistry. It's my privilege to present you the Christian Nadagam, a vibrant art form, elaborate costumes, and dramatic storytelling, blending indigenous performance traditions with influences from European opera.
This presentation is titled Pluripus Kadai, a small part, namely Parimarude Poratam. The story unfolds as the Turkish Emperor Albrad dispatches his two eminent soldiers on a critical mission to rescue his son Ferbras from the clutches of the Emperor Charlemagne. Meanwhile, Charlemagne sends his paladins to rescue his noble warriors. On the way, they meet in the forest, and the soldiers of Turk Emperor meet a tragic end at the hands of the paladins. This powerful production has been masterfully directed by Sri Abhilash Ashan and is presented by the esteemed Chavittu Nadaga Kala Kendra Center for Art and Research, an institution dedicated to preserving and promoting this valuable cultural treasure. Ladies and gentlemen, prepare to be transported to a world of stamping footsteps that echoes the heartbeat of tradition. Please join me in welcoming performers with a warm round of applause. സഹൃദയരായ കലാസ്നേഹികളെ, ദ്രാവിഡ നൃത്ത സംസ്കാരത്തെ വിസ്മയിപ്പിക്കുന്ന ചുവടുകൾക്കൊപ്പം അവതരിപ്പിക്കുന്ന മഹത്തായ കലാവിഷ്കാരമാണ് ചവിട്ടുനാടകം. 15-ാം നൂറ്റാണ്ടിലെ പോർച്ചുഗീസ് അധിനിവേശം കടലുകൾ കീഴടക്കി ഇന്ത്യയിലെത്തി നമ്മുടെ മലയാളക്കരയിലെ തീരദേശങ്ങളെയും സംസ്കാരങ്ങളെയും തൊട്ടുണർത്തി. യൂറോപ്യൻ നാടകരൂപങ്ങളെ കേരളീയ നാട്യ പാരമ്പര്യത്തിൻ്റെയും കളരിച്ചുവടുകളുടെയും ആത്മാവിൽ ചാലിച്ചുകൊണ്ട് പരിണാമം ചെയ്ത കലാ സംസ്കാരമാണ് ചവിട്ടുനാടകത്തിൽ പ്രതിധ്വനിക്കുന്നത്. മഹാരഥന്മാരായ രാജാക്കന്മാരെയും ധീരസേനാനികളെയും മഹത്തായ ഈ പാരമ്പര്യത്തിൻ്റെ ചിറകിൽ വർണ്ണവിസ്മയമാർന്ന വേഷഭൂഷാദികളോടെ ചെന്തമിഴ് ഭാഷയിലുള്ള ശീലുകളിൽ വീരരസത്തോടെ അവതരിപ്പിക്കുന്നു. രാഗസാന്ദ്രമായ സംഗീതവും നൃത്തവും നാടകീയതയും സമന്വയിപ്പിച്ചുകൊണ്ടുള്ള ഈ സംസ്കാരത്തുടിപ്പിൻ്റെ ഓരോ ചുവടിലും ചരിത്രത്തിൻ്റെ താളം മുഴങ്ങുന്നു. വാക്കുകൾക്ക് തീപിടിപ്പിക്കുന്ന, അരങ്ങിനെ പ്രകമ്പനം കൊള്ളിക്കുന്ന ദൃശ്യവിസ്മയത്തിലേക്ക് നമുക്ക് ചുവടുവെക്കാം. ചവിട്ടുനാടക കലാകേന്ദ്ര വിനയപുരസരം നിങ്ങൾക്ക് മുൻപിൽ അവതരിപ്പിക്കുന്നു ചരിത്ര സംഗീത ചവിട്ടുനാടകം പ്ലോറിപ്പസ് കഥൈ.
തന്നിടത്തിൽ നിന്റെ എങ്ങളെ നീ രക്ഷ ചെയ്യും ചോദിയാനാ താതച്ചുതൻ സ്പിരിത്ത് സാന്ത് തിരുനാമമദാൻ ആമേ.
സപ്പയോർപ്പടി.
ആദമേ വൈഗതി നീഞ്ച പാവാൽ ആദമേ വൈഗതി നീഞ്ച പാവാൽ അവനിയിൽ മർത്യ കുരുവായി വന്ന അവനിയിൽ മർത്യ ഋഷിയും ഐക്കന്നാളും നല്ല ഋഷിയും ഐക്കന്നാളും നല്ല തദനിലതോർ സ്തുതിയായി തദനിലതോർ സ്തുതിയായി വേദവികൽപമീ വെകിടമുറും അൽബ്രാത്തിൻ തനൈ വെകിടമുറും അൽബ്രാത്തിൻ തനൈ സത്യവേദം പുരിന്ത പൊല്ല സത്യവേദം പുരിന്ത പൊല്ല പ്ലോരിപ്പയാൾ കഥൈ പാടാം പ്ലോരിപ്പയാൾ കഥൈ പാടാം തന തന്നെ തത്തേം താനായി തത്തേം തന തന്നെ തത്തേം താനായി തത്തേം താനായി തത്തേം താനായി താനായി തത്തേം താനായി തന തന്നെ തത്തേം താനായി തത്തേം തന തന്നെ തത്തേം താനായി തത്തേം താനായി തത്തേം താനായി താനായി തത്തേം താനായി തിത്തരികിട്ടതി മൃദഗതിളങ്കിതക്കിടതി മൃദഗതികണത്തം
പുരാതന ഫ്രഞ്ച് ഭാഷയിൽ എഴുതപ്പെട്ട ചാൻസ് ആൻഡ് ദ ഗെസ്റ്റേ എന്ന മഹാവീര്യ കാവ്യത്തിൽ നിന്നും അടർത്തിയെടുത്ത ഒരേടാണ് ഞങ്ങൾ ഇന്നിവിടെ അവതരിപ്പിക്കുന്നത്. നല്ലവരായ നിങ്ങൾ ഓരോരുത്തരുടെയും ആശീർവാദത്തോടെ ഞങ്ങൾ ആരംഭിക്കട്ടെ ഭാര്യമാരുടെ പോരാട്ടം. ഉഗ്രപ്രതാപിയായ തുർക്ക് ചക്രവർത്തി അൽബ്രാത്തിന്റെ ദർബാർ. തന്റെ മകൻ ഫെറപ്രാസ് ഫ്രാൻസിൽ ബന്ദിയാക്കപ്പെട്ടിരിക്കുന്നുവെന്ന വാർത്ത ചാരന്മാർ വഴി അറിയുന്ന ചക്രവർത്തി തന്ത്രത്തിൽ ഫ്രാൻസിലെത്തി ഫെറപ്രാസിനെ മോചിപ്പിക്കാൻ ഉത്തരവിടുന്നു.
പൊങ്കും തുലുങ്കുമെങ്കും വങ്കർക്ക ദീപന, പൊങ്കും തുലുങ്കുമെങ്കും വങ്കർക്ക ദീപന, പൊങ്കും തുലുങ്കുമെങ്കും വങ്കർക്ക ദീപന, പൊങ്കും തുലുങ്കുമെങ്കും വങ്കർക്ക ദീപന. തുങ്കവൻ തളങ്ങളனை இங்கை மங்களனாய், துங்கவன் தளங்களனை இங்கை மங்களனாய், தங்கமுடே சிரசிலுங்க சிங்கன் மன்னவனாய், தங்கமுடி சிரசிலுங்க சிங்கன் மன்னவனாய். துர்க்கெம்பீரதோரிதோ வருகின்றாரே, துர்க்கெம்பீரதோரிதோ வருகின்றாரே. பொங்கும் துலுங்குமெங்கும் வங்கற்க தீபனா, பொங்கும் துலுங்குமெங்கும் வங்கற்க தீபனா. துர்க்கெம்பீரதோரிதோ வருகின்றாரே, துர்க்கெம்பீரதோரிதோ வருகின்றாரே. கிட்டரி கிட்டதி மிருதக திளங்கு தக்கிட்ட திமிர்தக ததிங்கிணத்தம் கர்தகத்தாம் தெய்யத்தாம் தகதகத தகதாம், தெய்யத்தாம் திகிதிகிதி திகிதீம், தெய்யத்தாம் தகதகத தகதாம் திகிதிகிதி திகிதீம் தகதக திகிதிகத்தா. கர்தகதம் கண்ணன் தாகிருதம் தாகிருதம் தத்தம் தொங்கண்ணன் தாகிருதம் தாகிருதம் தத்தம் தாம் தெய்யத்தாம் தகதகத தகதாம், தெய்யத்தாம் திகிதிகிதி திகிதீம், தெய்யத்தாம் தகதகத திகிதிகிதி தாம் தத்தீம் தத்தாய். மிருதத்ததிங்கணத்தம் மிருதத்ததிங்கணத்தம் தாதிந்தகத்தம். நேர்க்கும் படையோர் தன்னை உர்கருவிரை சேர்க்கும், நேர்க்கும் படையோர் தன்னை உர்கருவிரை சேர்க்கும். ஜனைகள் ஒன்றாயி வாழ்கின்றேன் நல்லா, ஜனைகள் ஒன்றாயி வாழ்கின்றேன் நல்லா. பார்க்குள்ளோர் பொல்லி என்ற உக்ர விக்கிரகம் தன்னை, பார்க்குள்ளோர் பொல்லி என்ற உக்ர விக்கிரகம் தன்னை. கற்கும் தூர்க்கெம்பிரதோர் தோன்றினாம் நல்லா, கற்கும் தூர்க்கெம்பிரதோர் தோன்றினாம் நல்லா. கார்க்கும் தூர்க்கெம்பிரதோர் தோன்றினாம் நல்லா, கார்க்கும் தூர்க்கெம்பிரதோர் தோன்றினாம். தித்தரி கிட்ட திமிர்தக திளங்கு தக்கிட்ட திமிர்தக ததிங்கிணத்தம்.
அலசாந்திரைக்கு இறைவனாம் பெரப்ராசின் வளர்ப்படையாம், கார்மான் படையே வண்டல் செய்து நாங்கள்,
வள்ளல் கார்மான் படையே வண்டல் செய்து நாங்கள்,
பிரியர் 5 பேரை சிறையில் வைத்தேன் நாங்கள்,
பிரியர் 5 பேரை தானிப்பந்தாய் தன்னை,
தந்தன்னை தாய் தன்னை தானனாய் தன்னை,
தந்தன்னை தாய் தன்னை தானிப்பந்தாய் தன்னை, தந்தன்னை தாய் தன்னை தானனாய். தித்தரி கிட்ட திமிர்தக திளங்கு தக்கிட்ட திமிர்தக ததிங்கிணத்தம். ஆனால் கேளும் கிங்கிர படையோர்களே, நீங்கள் வக்ரதையால் அந்த நீஜன் ஆர்மா நூறில் சென்று நமது மைந்தனை விடுதலை செய்து வரும் சீக்கிரம்.
അതിപ്രതാപവാനും ധർമ്മിഷ്ഠനുമായ ഷാർലിമേൻ ചക്രവർത്തിയുടെ ദർബാർ. തൂർക്കിലകപ്പെട്ടിരിക്കുന്ന തന്റെ പുത്രതുല്യരായ 5 ഭാര്യമാരെ രക്ഷിക്കുവാൻ ശേഷിച്ച ഭാര്യമാരെ ചക്രവർത്തി ചുമതലപ്പെടുത്തുന്നു.
നവമംഗളമിതിലെങ്കും പൊങ്കുലെങ്കും നവമംഗളമിതിലെങ്കും പൊങ്കുലെങ്കും നവമംഗളമിതിലെങ്കും തുങ്കാനേനും കാർമാൻ കൊല്ലുവില്ലിതോ വരാർകൾ തുങ്കാനേനും കാർമാൻ കൊല്ലുവില്ലിതോ വരാർകൾ ചങ്കை ചേർച്ചെറു ചിങ്കർ ചേனை താളങ്ങളെങ്കും ചങ്കை ചേർച്ചെറു ചിങ്കർ ചേனை താളങ്ങളെങ്കും പോരിലെങ്കും വീരനെമ്പീരതോർ വരാർകൾ പോരിലെങ്കും വീരനെമ്പീരതോർ വരാർകൾ പൊങ്കുലെങ്കും നവമംഗളമിതിലെങ്കും പൊങ്കുലെങ്കും നവമംഗളമിതിലെങ്കും തുങ്കാനേനും കാർമാൻ കൊല്ലുവില്ലിതോ വരാർകൾ തുങ്കാനേനും കാർമാൻ കൊല്ലുവില്ലിതോ വരാർകൾ
കർദഗതാം തെയ്യത്താം തകതകതത്തികിതികിതിത്താ തം തിമൃതത്തം താദിന്ദഗത്തം കർദഗതം കർദഗതത്തരി തകതരി തകതളം ദത്തരി തൊന്തരി തകതരി താ തിമൃതത്തതിഗണതം കർദഗതത്തരി തകതരി തകതളം ദത്തരി തൊന്തരി തകതരി താ തിമൃതത്തതിഗണതം കർദഗതത്തരി തകതരി താ തിമൃതത്തതിഗണതം കർദഗതൊന്തരി തകതരി താ തിമൃതത്തതിഗണതം കർദഗതത്തരി താങ്കൃതക തകതരി താങ്കൃതക തൊന്തരി താങ്കൃതക തകതരി താങ്കൃതതാം കർദഗതത്തരിഗണ തകതരിഗണ തൊന്തരിഗണ തകതരിഗണതാം തത്തീം തത്തായ് തിമൃതത്തതിഗണതം തിമൃതത്തതിഗണതം താദിന്ദഗത്തം
പാരിൽ പുകൾ കൊണ്ട പ്രബല പ്രതാപന കാരൽ സ്മാൻ രാജൻ നാനേ മണ്ണിൽ മഹിமை சேர் மன்னன் மனுவர் தன்னுடைய സിംഹാസനത്തിൽ അലങ്കാരൻ സിംഹാസനത്തിൽ അലങ്കാരൻ നല്ല പൂർണ്ണ ചന്ദ്രബിംബ വദന കാന്തിയും പൂർണ്ണ ചന്ദ്രബിംബ വദന കാന്തിയും ഭുവനിയിൽ തിരശൂരുല കേന്ദ്രൻ താതൻ തൻ നാമം ദിനവും തുതിപ്പവരില്ലാത്തവരെന്നാൽ പൊരുതിടുമുടനടി പാർവേന്തൻ താകുടജം തരികുട ജന്തമി താകുടജം സരിഗമ പദനിസ താനിപ്പം തന്നെ തന്നെ തനനായി താനിപ്പം തന്നെ തനനായി താനിപ്പം തന്നെ തിന്ത തോതാകൃതി തരികിടതി തോതാകൃതി തെയ്യത്തോ താതിന്തകത്തം
பாரிலுயர் பெற்றோங்கும் கோட்டும் படை வீரர் நாங்கள்
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 கோட்டும் படை வீரர் நாங்கள் பத்திசை புகழ் பெரிய பாரி வீரர் நாங்கள்
பத்திசை புகழ் பெரிய பாரி வீரர்
நாங்கள் பத்திசை புகழ் பெரிய பாரி வீரர் நாங்கள்
பத்திசை புகழ் பெரிய பாரி வீரர்
தித்தரிகிட்டது மிருதகத்திலங்கு தக்கிட்டது மிருதகத்திங்கிடத்தம் பரிபாலர் 5 பேரை பார்த்து காத்து வேண்டுவதற்காய்
பரிபாலர் 5 பேரை பார்த்து காத்து
வேண்டுவதற்காய் உயபாரன் தனைய நம்பி உண்மையுடன் நாங்கள்
உயபாரன் தனைய நம்பி உண்மையுடன்
நாங்கள் உய்யாபாரன் தனைய நம்பி உண்மையுடன் நாங்கள்
உயபாரன் தனைய நம்பி உண்மையுடன்
தித்தரிகிட்டது மிருதகத்திலங்கு தக்கிட்டது மிருதகத்திங்கிடத்தம் சீரிலுயர் பெரிய மல்லரசன் தன்னீதிகள்
சீரிலுயர் பெரிய மல்லரசன் தன்னீதிகள்
மல்லரசன் தன்னீதிகள் சீக்கிரம் செய்யுதற்காய் நாங்கள் இதோ நல்ல
சீக்கிரம் செய்யுதற்காய் நாங்கள் இதோ
நல்ல சீக்கிரம் செய்யுதற்காய் நாங்கள் இதோ நல்ல
சீக்கிரம் செய்யுதற்காய் நாங்கள் இதோ
தித்தரிகிட்டது மிருதகத்திலங்கு தக்கிட்டது மிருதகத்திங்கிடத்தம் பெரிய கார்மான் துறைக்கு வணக்கம்.
எந்தன்னில் பிறவியே போல் என்னை காக்கும் வீரரேக்கே அந்த கனல் பிராத்தன்னூரில் அஞ்சிடாதே நீங்கள் ஒன்றான நமது தேவன் உண்மை சேர்ப்பாதம் நம்பி ஒன்றலனு காமல் நீங்கள் தம்பிமாரே ரச்ச செய்யும்
தாகிருதத்தம் தகதிந்த தகஜமித தையத்தாத்து மர்தகத திங்கினத்தம்.
തന്ത്രപൂർവ്വം ഫ്രാൻസിലേക്ക് കടന്നുകയറാൻ ശ്രമിക്കുന്ന തൂർക്കുപട തങ്ങളുടെ രാജ്യാതിർത്തിയിലെ കാനനപാതയിൽ വഴിതെറ്റിയലയുന്ന പാരിമാരെ കാണുകയും അവരെ ആക്രമിക്കുകയും പാരിമാരാൽ വധിക്കപ്പെടുകയും ചെയ്യുന്നു.
അത്തവനരജൻ അൽബ്രാത്തരുളിയ പടി പോൽ ചെയ്യാൻ
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 അന്തകരിங்கே நாங்கள் தந்திரமோடே அங்கே
அந்தகரிங்கே நாங்கள் தந்திரமோடே அங்கே
தன 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 நாய் தானிப்ப தன 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 நாய் ஹா ஹா
தன தன நாய் தானிப்ப தன 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 நாய் ஹா ஹா
தன 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 நாய் தானிப்ப தன 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 நாய் தன்னை
தன 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 நாய்
தன 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 நாய் தானிப்ப தன 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 நாய் ஹா ஹா
தன 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 நாய் தானிப்ப தன 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 நாய் ஹா ஹா
தன 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 நாய் தானிப்ப தன 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 நாய் தன்னை
தன 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 நாய் தானிப்ப தன 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 நாய் தன்னை
தன 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 நாய் தானிப்ப தன 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 நாய்
பாதை தெரியாமல் கடிதினில் நாங்கள் கட்டளை படியாலகி
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 பதிதன் பட்டணத்தில் சேரும் வரை பாதுகாத்திடும் பராபரா
கொடுமையுடன் படை செய்யும் கொடிய கர்மன் கூட்டரே
கொடுமையுடன் படை செய்யும் கொடிய கர்மன் கூட்டரே
ஊருரை பேர் சொல்லாமல் விடுவதில்லை வீரரே
ஒருரை பேர் சொல்லாமல் விடுவதில்லை வீரரே விடுவதில்லை நெஞ்சுரைத்த வெறி விளங்கும் வெந்தரே
விடுவதில்லை நெஞ்சுரைத்த வெறி விளங்கும் வெந்தரே
ஒட்ட வாழ்கிறையிடுவன் வெட்டி வதை செய்வேன்
ஒட்ட வாழ்கிறையிடுவன் வெட்டி வதை செய்வேன்
தன தன்னை 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 தன்னோ தனாய் தன்னை
தன்னை தன்னை தன்னை தன்னோ தன்னாய் தன்னை
தன தன்னை 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 தன்னோ தனாய் தன்னை
தன்னை தன்னை தன்னை தன்னோ தன்னாய் தன்னை
தானானே
தன்னை 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 தன்னோ தன்னாய் தன்னை
தன தன்னை 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 தன்னோ தனாய் தன்னை
தன்னை தன்னை தன்னை தன்னோ தன்னாய் தன்னை
தன தன்னை 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 தன்னோ தனாய் தன்னை
தானானே
தித்தரி கிட்டத்து மிருதக்கத்தில் அங்கித கிட்டத்து மிருதக்கத்தின் பழக்கம்
ഈ നാടകത്തിൽ അഭിനയിച്ച കലാകാരന്മാർ ഒന്നിച്ചണിനിരന്ന് മംഗളം ചൊല്ലി വിട ചോദിക്കുന്നതോടെ ഈ നാടകം ഇന്നിവിടെ പൂർണ്ണമാകുകയാണ്. ഞങ്ങൾ തുടരട്ടെ. മംഗളം.
പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാർത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
തിരുലോകതാതനേശു പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
താം തെയ്യത്താം തകതകതത്തികിതികിതിത്താ തിമൃതത്തതിങ്ങണത്തം താതിന്തകത്തം അന്നേ മരിയ തായെ കന്നിവൂറും കന്നിയാരെ
അന്നേ മരിയ തായെ കനിവൂറും കന്നിയാരെ
കനിവൂറും കന്നിയാരെ മകിതേ മകാത്മജയെ
കനിവൂറും കന്നിയാരെ മകിതേ മകാത്മജയെ
തിരുലോകതാതനേശു പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
താം തെയ്യത്താം തകതകതത്തികിതികിതിത്താ തിമൃതത്തതിങ്ങണത്തം താതിന്തകത്തം താതൻ ചോദൻ സ്പിരിത്ത് സേന്ത തിരുനാമമതാലെ
താതൻ ചൂതൻ സ്പിരിത്ത് സേന്ത തിരുനാമമതാലെ
തിരുനാമമതാലെ പാരിൻ പരനെ പണിന്തിടുന്നേ
തിരുനാമമതാലെ പാരിൻ പരനെ പണിന്തിടുന്നേ
തിരുനാമമതാലെ പാരിൻ പരനെ പണിന്തിടുന്നേ
തിരുനാമമതാലെ പാരിൻ പരനെ പണിന്തിടുന്നേ
തിരുലോകതാതനേശു പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
തിരുലോകതാതനേശു പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
തിരുലോകതാതനേശു പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
തിരുലോകതാതനേശു പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
തിരുലോകതാതനേശു പരനേയൂരത്തനെയും
തിരുലോകതാതനേശു പരനേ പൂരത്തനെയും
പാരിന്നൂരത്തനെയും പരനെ നീ കാത്തിടേണേ
ആരിന്നൂരത്തനെയും പരനേ നീ കാത്തിടേണേ
താം തെയ്യത്താം തകതകതത്തികിതികിതിത്താ തിമൃതത്തതിങ്ങണത്തം താതിന്തകത്തം
That was a power-packed performance. On behalf of the organizing committee and all our delegates and guests gathered here, I express our heartfelt appreciation to the Chautunadaka Kala Kendra Center for Sri Abhilash KM for bringing the epic tale of Ploripus to life before our eyes. I also express our sincere appreciation to the talented artists Jackson Jobin, Alan Figueredo, Jidul Joseph, Anna Sandrina Sabu, Aljan Benny, Ciara Ann Maria KB, Bia Shibu, Adarsh Anthony, and Agil Jospi. Thank you all. We will now move on with the valedictory function of ICIT 2025. Good afternoon to one and all gathered here. With immense joy and deep sense of fulfillment, we welcome you to the valedictory function of the International Conference on Sustainable and Indigenous Technologies and Cultures, ICIT 2025, hosted by St. Thomas College, Autonomous Thrissur. Over the last few days, we have witnessed thought-provoking presentations, meaningful discussions, and enriching academic exchanges. Today, we gather here to celebrate the successful culmination of this prestigious conference. To commence this program with divine blessings, may I invite Ms. Gautami P., Research Scholar, Department of Statistics, to lead us in prayer.
ധർമ്മം നിലനിർത്തുന്നതിനായി നാളിൽ നാളിൽ പല മട്ടവതാരമാർന്നിഴും ചിത്ഫലമേ നമ്മളിലേക്കിടട്ടെ ഭവ്യം കരണീയമറിഞ്ഞിടാതെ എന്നും കര കാണാത്ത ഭവാർണവത്തിൽ നീന്തി കരയുന്നവരെ കനിഞ്ഞുവേകാൽ കരകേറ്റും ഗുരു കാത്തിടട്ടെ നമ്മെ ഉലകന്ധതയിൽ പതിക്കെ ധർമ്മം നിലനിർത്തുന്നതിനായി നാളിൽ നാളിൽ പല മട്ടവതാരമാർന്നിഴും ചിത്ഫലമേ നമ്മളിലേക്കിടട്ടെ ഭവ്യം.
Thank you, Gautami. Now, to formally welcome the gathering, I'm pleased to invite Dr. Jency Thomas, Joint Coordinator of the R&D Cell, to deliver the welcome address.
Good afternoon. We are coming to the end of our 3-day conference on sustainable and indigenous technologies and cultures, ICIT 2025. And this year we had 10 thrust areas. Leonardo da Vinci once said, and I quote, "All our knowledge has its origin in our perceptions." I hope this conference has brought together different perspectives of technologies and cultures from the viewpoint of being sustainable yet indigenous. As we gather here for the valedictory session, I would like to welcome you all, esteemed guests present online and offline, both on stage and off stage, for this session. I would like to welcome my vibrant Vice Principal, Reverend Father Anil George. He has extended enormous support in shaping the quality initiatives of our college. And under his aegis, as the IQAC coordinator, our college secured A++ in the NAC 4th cycle. Welcome, Father. I take this opportunity to welcome our special guest, Dr. K. Muralidharan, our prestigious alumni. Yesterday he said, "Dear students, you won't understand this, but after 10-15 years, when you come back to your alma mater, you will have a sense of belonging which words cannot express." And I could feel it for the past 2 days. He was so overwhelmed and so full of joy. You can see the joy on his face. We are so honored to have you and your wife here amidst us today for this function. Thank you, sir. Thank you, ma'am. I would also like to welcome the dynamic conveners of this program, Dr. Sheba, the Director of IKS and Convener ICIT, the joint conveners, Dr. Geedu Elizabeth and Dr. John Paul CI. They have been quite instrumental in organizing this conference. They have plenty of responsibilities, yes, yet the conference went off quite smooth. Welcome. We are working as a joint coordinator of the Research Council. We have we are two sides of the same coin. I have a joint coordinator with me, Dr. Viju MJ, and we are working under the agents of our Dean of Research, Dr. Joyce Jose. So I extend a warm welcome to both of you. I also would like to welcome a few people off the dais and in their absentia, because without them, an event like this would not have been possible. Reverend Dr. Martin K., our principal, Reverend Biju, Father Biju Paningadan, our executive manager, Dr. Divya George, our IQSC coordinator, Dr. John Snudworth, the Dean of Innovation and Startups, our vice principals, Dr. Vimla Jose, along with Dr. Fevin Baby, the deans, head of the departments, I extend a heartfelt welcome to all of you. I also welcome all the committee members, seminar chairs and judges, especially Dr. Raju CP, Associate Professor and Head of the Department, St. Aloysius College. He has been with us for the past 2 days, and he has been a session chair and judge for a lot of sessions in the arts domain. Thank you so much, sir, for joining us, and hearty welcome to this program. Our research scholars are the backbone of this R&D cell, although they cannot be physically present in all the sessions, but without them, the R&D programs cannot be run. So wherever they are, I welcome you all to this program. I also extend a warm welcome to all the committee members, colleagues, and supporting staff and students to the valedictory session. The participants present online and offline, hearty welcome. We look forward to you in future programs as well. Thank you.
Thank you, Jansi ma'am. Now it's my privilege to invite Dr. Anil George K., Vice Principal of St. Thomas College, Thrissur, to deliver the presidential address.
Good afternoon, everyone. Professor K. Muralidharan, Dr. Sister Sheba, the convener of this international conference, Dr. Joyce, the Dean of Research, Dr. Geedu, Dr. Viju, Dr. Jansi, and all honorable invited guests, faculty members, participants, and my dear students. Now today we come to the end of this international multidisciplinary conference, but there has been a very long journey for the organization and the conduct of this specific seminar. For the last many years, the research department has been organizing international conferences every year, but this year it has been quite different because we had the thought to put it a different way, incorporating the culture of our land into the conference. One would wonder what is the place for Chavuttu Nadagam to the close of an international conference like this. But then this has been an initiative, an attempt to revive the lost art forms of India and specifically that of Kerala. And to my great surprise, it has been a wonderful performance this afternoon. I would like to congratulate everyone behind this wonderful art form. In fact, I have seen this art form only 1 or 2 times before, but this has been the best I have ever seen, the Chavuttu Nadagam. Thank you so much for this. And as far as the organization of this conference is concerned, if you look, take stock of the conferences that we had in the previous years, I would say this has been the conference with the highest number of participants. We had 241 registrations for this international conference. And to the greatest surprise, we had, very good now, 128 research presentations in these seminars. Truly overwhelming. So I think so much has gone to the, efforts to organize this seminar in such a overwhelming manner, wonderful manner. I would like to congratulate Dr. Sister Sheba and all her, team members for taking so much pain, so much effort, so much of, coordination, teamwork to make this happen. Of course, this has been, we have been conducting under the aegis of research cell, under the leadership of Dr. Joyce. But this year, the leadership went to IKES as well, and Sister Sheba, Dr. Gidu, and IQAC coordinator, Dr. Divya George, Dr. Johns, Dr. John Paul, the joint convener, many others. And I would like to specially mention the efforts of the research scholars for the success of this seminar conference. I have been, observing the way the research scholars who have been, running here and there with so much of zeal and passion. And that is the main reason for the success of this seminar. So thank you so much, research scholars, and congratulations to all of you. So I think the big takeaway of this conference would be definitely, how to organize a conference like this in a meticulous manner. Of course, we might have had lots of shortcomings. Those were all not shortcomings, basically. They all are lessons for us to organize in a much better way in the days to come. So I, again, on behalf of principal and the management, I would like to congratulate everyone involved in the organization and the conduct of this international conference. I hope in the years to come, we will be able to organize in much better manner with many more participations as well. I would like to also acknowledge the presence of Professor K. Murali and the proud alumnus of St. Thomas College. Yesterday when I listened to him, he said he went emotional, but I myself went emotional. It was truly, heartwarming to listen to him. And to our great happiness, he has been here for the last 5 years, and he will be here in Thrissur. I am sure he will be at our help for us to mentor us, for us, to take the right path in the research. He has got vast experience in the domain of research, and therefore he will be, hand-holding us in the days to come, and that will be great asset for us. I thank in anticipation for that to Dr. Professor K. Muralidharan. So thank you so much. I wish you all the best. Thank you one and all.
Thank you, Father, for the insightful words. Now, we arrive at an important highlight of today's ceremony, the Best Paper Presentation Awards. I request Dr. Muralidharan, former director of CSIR, Central Glass and Ceramic Research Institute, to kindly present the awards to the deserving recipients. Theme 1, Vedic Mathematics and Traditional Sciences. Best Paper Award goes to Julie Thomas, Alfonsa College, Pala, for the paper titled The Relation Between Mathematics and Kerala. These are the certificates for online presentations. Theme 2, Computing Technologies. The Best Paper Award goes to Adityan VP from St. Thomas College, Autonomous Thrissur, for the paper titled Multitask Urban Feature Analysis from Aerial Imagery, Superior Building Segmentation with FPN ResNet 101. Third theme, Nature and Ecology in Indian Traditions. The Best Paper Award goes to Dinsi K. Litton, St. Thomas College, Autonomous Thrissur, for the paper titled Isolation, Identification and Antibacterial Studies of Endophytic Fungus from Rhizome of Syngiber cerumbet, Smith, a medicinal plant. Congrats, Dancy. Now for the fourth theme, Indigenous Medical Systems and Healthcare. The best paper award goes to Afghan Ann from Bharathiya University for the paper titled Cohorts in Aquaculture, Nutritional Drivers of Sustainable and Next Generation Feed Development. Theme 5, Sustainable Energy and Environmental Practices. The best paper award goes to Sandra Joy from St. Thomas College, Autonomous Thrissur for the paper titled Synthesis and Application of Poly and Methylalanil for the removal of chromium-6 from water. Congrats, Sandra. Now moving on to the sixth theme, impact of IKS in literature and media and blending IKS and NEP. The best paper award goes to Anjali A.N., St. Thomas College, Autonomous Thrissur for the paper titled Revitalizing Language Learning, IKS-Driven Strategies to Reduce Language Anxiety in NEP 2020. Congrats, Anjali. Now for the seventh theme, Indian Languages, Origin and Prospects. The best paper award goes to Nisha John from St. Aloysius College, Elthuruthu for the paper titled Bharatiya Vaiknyanika Sampradayagalude Samrakshanam Agashavaaniyilude. In her absence, Raju sir will be receiving the best paper award. Now for the eighth theme, Evolving Sustainable and Indigenous Economies and Trade Culture, the best paper award goes to Harikrishnan AP and Dr. Sajeev H. from Government Arts College, Thaikad, Trivandrum for the paper titled Crafting Sustainability, Indigenous Knowledge and Industrial Transition in Kerala's Pottery Sector. Congrats, Harikrishnan. Now for the ninth theme, Indigenous Philosophies and Cultures and Beyond, the best paper award goes to Ardra T.R. and Dhanu Terampil from St. Thomas College, Autonomous Thrissur for the paper titled Snow Lotus. I now invite Dr. Raju CP, Associate Professor and Head, Department of Hindi from St. Aloysius College, Elthuruthu, who has been a gracious judge here for the past 2 days, and I invite him to collect his certificate from Dr. Anil George. Now we will move on with the certificates for presenters. Dr. Sanesh C., Assistant Professor, Department of Commerce, Sri Vyasa NSS College, Vadakanjeri. Ms. Kartika K., Research Scholar, Department of Zoology, St. Thomas College, Autonomous Thrissur. Ms. Kribalakshmi M., Student, Department of English, St. Thomas College, Autonomous Thrissur. Ms. Minnu Joseph, Student, Department of English, St. Thomas College, Autonomous Thrissur. Ms. Sheetal Peter, Student, Department of Botany, St. Thomas College, Autonomous Thrissur. Ms. Tamanna Shaju, student, Department of Zoology, Vimala College, Autonomous, Thrissur. Ms. Adira Vijay, Assistant Professor, Department of Commerce, IT and E-Commerce, Sri Krishna Arts and Science College. Ms. Sharanya SS, Research Scholar, Department of Division of Bioceramics, Sri Chitra Tirunal Institute for Medical Science and Technology Wing. Ms. Arya ND, Research Scholar, Department of Commerce, Christ College, Autonomous, Irinalakuda. Ms. Najia Hiba K, student, Department of Law, KMCT Law College, Kuttipuram. Ms. Sanimol AP, student, Department of Law, KMCT Law College, Kuttipuram. For the participants of St. Thomas College, students can collect it from the office. Hearty congratulations to all the award winners for their excellent scholarly contributions. Now, for the felicitation, to offer words of appreciation and encouragement, I invite Dr. Viju MG, Joint Coordinator of R&D Cell.
Respected dignitaries on the and off the dais, esteemed researchers, dear colleagues, dear resource persons, and dear participants. As we are drawing curtains of 3-day international conference on indigenous and sustainable technologies and cultures, I am standing with pride and gratitude to propose felicitation on this occasion. When we talk about the journey of this particular conference, I know we have started as a modest research scholars meet in the beginning, and later it is evolved as a one-day gathering, and this transformed into a national seminar, and last year it became a 2-day international conference, and this year it became, actually we have planned for 2 days, but it became a magnificent 3-day global platform, as we have done it on online and offline. When we consider this year's achievements, our Vice Principal, Father Anil, has mentioned about how far we have gone regarding this conference. There were 140 research papers, registrations, over 200 participants engaged in this, most of the sessions, and most of the sessions were online and offline. And we explored diverse dimensions of Indian knowledge systems and indigenous technologies during this conference. So I would like to acknowledge and congratulate, being the joint coordinator of the research team, especially our principal. He is the pillar of this conference, as well as our team. Dr. Martin K., our principal. Dean of Research, Joyce, and other team members of her. And also I would like to appreciate the presence of vice principals, deans, judges, and chairs during this conference. Also, I would like to appreciate the presence of IKS Director Dr. Shiba. Sister Shiba, she is the coordinator of this particular conference. She had coordinated it with vision and dedication. I congratulate on behalf of the team, Sister Shiba and her team, especially joint coordinators, Gidu Miss and Dr. John Paul, sorry. Also, I would like to congratulate all the research scholars and guides who worked tirelessly behind the scenes to make it a grand success. participants were from different parts of our country and some of them attended it online. Even our own scholars and postgraduate students, we could witness their enthusiasm that made the program a resounding success. I congratulate all the participants who have attended this program, especially from our college and from nearby colleges and from our country parts. So at this time I would like to recollect physicist Freeman Dyson's observation: science is not a monolithic body of doctrine. Science is a culture, constantly evolving and changing. Actually, that motto or that theory of Freeman is really visible. That embodies the spirit of our conference, that is bridging ancient wisdom with contemporary inquiry. Also, I would like to mention, recently I happened to read Lawrence Simon of Belgium, who earned PhD at the age of 15. Surely that will be a great inspiration for our scholars, that blazed an academic trail through dedication and passion, and that should be inculcated by research scholars. So I would like to appreciate the research scholars and kindly carry forward the momentum that you got from this conference. Complete your work with the same excellence and demonstrate here being the different members of different committees. Please keep the spirit of inquiry alive. Through sustained effort, knowledge truly advances that we could come across through this conference. So on behalf of the research team, I thank you all for making ICIT 2025 a memorable success. Thank you all.
Thank you, Dr. Viju, for your thoughtful felicitation. Now, to extend our gratitude to everyone who contributed to the success of ICIT 2025, I invite Dr. Guido Elizabeth T., Joint Coordinator, ICIT 2025, to propose the vote of thanks.
Honorable Principal Reverend Dr. Martin K. in his absentia, Dr. Anil George, President of the meeting, respected dignitaries, esteemed delegates, faculty members, research scholars, and dear participants. It's my privilege and honor to propose the vote of thanks on behalf of St. Thomas College, Thrissur, at the conclusion of this remarkable international conference held from the 1st of December 2025. The International Conference on Sustainable and Indigenous Technologies and Culture was jointly organized by the R&D Cell, IKSL, IDC, IIC, and IQAC of St. Thomas College, Thrissur. The conference, being the flagship program of R&D Cell, is a significant event of the college. The program, inaugurated by Dr. Multtidisciplinary, former Pro-VC of Sri Shankara Sanskrit University, Kaladi, had eminent speakers like Dr. K. Muralidharan, former Director of CSIR CGCRI, Professor Shashi Pallikadavathu, University of Portsmouth, Dr. Darshana Maniyathu Shashi, University of Texas, USA, and Dr. Neha Singhal, Delhi University in Hybrid Mode. We had near to 300 registered participants and 140 research papers under 9 theme areas. The extended abstracts have been published as 3 ISBN books and 1 ISSN journal. In addition, authors can submit the full papers for publications in Scopus Index journals. With this note, I shall enter my duty to propose the vote of thanks. First and foremost, I extend our deepest gratitude to our distinguished guest whose presence has truly elevated this event. We are immensely grateful to Dr. Multtidisciplinary, former Pro-Vice Chancellor of Sri Shankara Sanskrit University, Kaladi, for inaugurating the conference and delivering the keynote address. Next, I would like to extend our deep-felt gratitude to Dr. K. Muralidharan, former Director of CSIR CGCRI, and our alumnus for gracing the occasion, sharing his invaluable insights on 2 days of the program. Thank you very much, sir. Thank you, Lakshmi ma'am, for coming here and being with us today. Our sincere gratitude also go to our eminent international speakers, Professor Shashi Pallikadavat from United Kingdom and Darshana Manyathu Shashi from University of Texas, USA, for bringing global perspectives to these 2 days of intellectual exchange. We express our heartfelt appreciation to Dr. Neha Singhal from Delhi University for her enlightening contributions. Even though Professor Dr. Biju Kumar V.C. Kufos and Dr. Anjana Bhaganathan and NIT Calicut couldn't grace this occasion through their presence due to unavoidable professional and personal commitments, we extend our sincere gratitude for their blessings. We are grateful to His Excellency Ma Tony Nilankaval, our manager, for his constant support. We extend our sincere gratitude to our principal, Reverend Father Dr. Martin K. in his absentia for all the support rendered towards the conference. A special thanks to Reverend Father Biju Banengadan, our executive manager, for supporting all the endeavors conducted at the college. We extend our sincere gratitude to all the vice principals, especially Dr. Anil George K., for gracing this occasion and delivering the presidential address. We extend a heartfelt gratitude to Dr. Joyce Jose, Dean of Research, Dr. Jency Thomas, and Dr. Viju MJ, Joint Coordinators of R&D Cell, for their sincere efforts and tireless nights. We extend our sincere gratitude to Dr. Sheba Siri, Director IKS and convener of this conference, for all her efforts. Words are not enough for her efforts, sister. Thank you. I extend my thanks to Dr. Divya George, IQAC coordinator, for her support throughout the program. Sincere gratitude towards Dr. Jones Nadwath, Dean of Innovations and Startup, and Dr. John Paul, joint convener of this conference. And I would like to especially thank Mr. Sutish Kumar, our project manager, for his support for this conference. I extend my sincere gratitude to all the chairs and judges, especially Raju sir from St. Aloysius College, Elturat, without whom this venture wouldn't be complete. Thank you all. We extend sincere gratitude to the organizing committee, which include reception committee led by Dr. Vimala Jose and Dr. Vimala K. John, certificate committee led by Dr. Gina Joseph, technical committee led by Dr. John Paul, award committee led by Dr. Sabu A.S., food committee led by Dr. Flurjan Anthony, Ranjit sir and Ajit sir, registration committee Dr. Anne Mary, program committee Dr. Anu Paul, finance committee Dr. Vipin Benne, publicity committee Dr. Anto PV and Father Stishan, cultural event Dr. Santya. A big thanks to all of you and all the research scholars who were the backbone of this program. Thank you all for your tireless efforts, dear research scholars. A special thanks to the editors of the books and journals, especially Rohini Miss, Jensi Miss, Vipin sir, Biju sir, Regin sir, and Shemi Miss. Thank you very much. A heartfelt gratitude to all the participants who attended the event in online and offline mode, and special thanks to all the contributory speakers. We also express our sincere thanks for the cultural enrichment offered to the traditional performance of Chautu Nadagam. We extend our sincere thanks to the financial support rendered by the management and private sponsors. Happy Dinstar Private Limited, Swarnamugi Gold and Diamonds, TBNO Opticals, Global Education Consultants, Third Eye Security Systems, and MyFin TV, other private sponsors. We thank you all. Our thanks to all our faculty members, UG and PG students, student volunteers, technical staff, non-teaching staff, and all the participants who have worked tirelessly behind the scene to ensure the smooth execution of each and every session. To everyone present here today, thank you for your active participation, valuable interactions, and continued support. We hope the connections made and ideas generated during these 3 days will inspire new directions in research and collaboration. Thank you all once again, and we'll look forward to meet you in future academic endeavors. Thank you.
Thank you, Dr. Geetu, for expressing our collective appreciation. Now, as we draw the curtains of ICIT 2025, let us take a moment to reflect on what we have accomplished together. This conference has not merely been a platform for academic dialogue, but a celebration of innovation rooted in tradition, a fusion of sustainable and indigenous technologies that hold immense promise for our shared future. On behalf of the organizing committee, we express our heartfelt gratitude, and may the insights gained here guide us towards a more sustainable, culturally rooted and innovative tomorrow. With this, we officially conclude the valedictory function of ICIT 2025. Thank you all for your presence, your enthusiasm, and your unwavering support. Wishing each one of you a fulfilling and inspiring journey ahead. Also, duty certificates can be collected from the desk, and please do partake in the lunch arranged at room number 18. Thank you.